The Joe Rogan Experience.
Train by day, Joe Rogan podcast by night, all day.
All right, we're live. We can't hear ourselves because Brian Cox, even though he's a musician, he goes no headphone.
Well, we can still hear ourselves, can't we?
I can hear you. You're right. We just can't hear whether or not, but we wouldn't know anyway. What would we do? He knows. He's got headphones on. You're right. This is revolutionary. From now on, no more headphones. It's ridiculous.
What would you use them for?
Well, it's like watching television while you're on television. It's like if you were on TV and you were watching a video monitor. It seems weird.
Yeah.
It's a little redundant.
I think we should cast them aside.
Yeah, let's just
in a revolutionary act.
Push them away. Like, not just put them down, pushing them away. We reject you, oh headphones. We reject you. Amazing technology. Infinite monkey cage.
Yeah.
What's going on, man? What is this? First of all, I'm a huge fan of your work. I said that when you came in, but I have to tell people online. This is a huge treat for me. I'm very excited. Space has been my all-time adult freak-out pleasure. I love watching space documentaries. I love watching television shows on space. So having you in here is a huge treat.
Thank you.
What's Infinite Monkey Cage?
It's a long-running now BBC radio show. So the idea initially was to get scientists to talk about their science, whatever it may be. As you said, cosmology or archaeology, human origins, mathematics, anything. And then I do it with a stand-up comedian called Robin Ince. He's a very good friend of mine. And we always also invite another guest who will be a comedian sometimes or an actor or someone who will kind of ask those questions that come in from left field. But it always goes off into some, as your podcasts do. It just you never know where it's going to go. So we record it in front of a live audience, usually in London, and we record for about 2 hours usually and broadcast it for about 30 minutes. And there's a podcast as well, which is a bit longer. But we decided to bring it to the States because there are lots of scientists in the States, lots of comedians, and people like yourself that are going to do it with us in 3 weeks, isn't it?
Yeah,
is it
3 weeks.
Thursday the 12th in LA.
Yes.
And so we just wanted. So we're going to record them for the BBC, and they're going to be on the podcast and broadcast in the UK, but also in front of a live audience. So it's someone asked me this morning actually, and I said it's kind of like a variety show. And I said, do you have those in the States? I said, yeah, we used to have them. We used to have them. Dean Martin used to do one. So I said, well, it's kind of like if Dean Martin had a PhD, then he would have been that in black and white, a bit of singing, a bit of dancing, a bit of quantum mechanics, basically.
Well, that's one of the things that's so important about what you do, what Neil deGrasse Tyson does, is that you guys, you're entertaining as well as having a genuine passion and a deep knowledge of science. So it's not just like, here's the cold, hard facts, which are amazing and fascinating on their own, but you guys both have this way of sort of germinating these ideas into people's minds that might not ordinarily accept them because there's a lot of people in America, especially, that associate learning with boring.
Well, I think the important point, the serious point, is that science is too important not to be part of popular culture. So popular culture is the thing that people discuss. So if we cede that to, talent shows or sports or whatever it is, then we're removing the most important area of human endeavour out of general conversation. So I think there's a responsibility on scientists to say, well, I accept that, of course, I can't talk at the level that I lecture at as an undergraduate lecture course at university or even a postgrad lecture course at the level of my thesis or my research. I can't do that. But it's extremely important that we don't just cede all the ground. We don't want people in bars tonight or wherever, in restaurants, to be talking about the Grammys last night.
Right.
We would like them to be talking about the fact that the universe may be infinite in extent. They're asking questions such as, how many civilizations are there in the Milky Way galaxy? The answer might be, not very many. If that's true, then what does that mean for the way that we behave? These are important questions, but they will never be debated unless we take the time and make the effort to make the science and the ideas and the debate around them part of popular culture.
The internet has also opened up a lot of people's ideas about what science can be, and also it opened up a lot of people's ideas about the actual popularity of science, because there's until, maybe 10, 20 years ago, with the notable exception of like maybe Carl Sagan and a few other famous people that became famous for, either cosmologists or mathematicians, it's very, very rare. But now you're seeing guys like yourself, guys like Neil deGrasse Tyson. It's like more and more Richard Dawkins, Christopher Hitchens while he's alive. These interesting intellectuals become much more mainstream. They become, because people realize it wasn't that folks weren't interested in these subjects before, it's just they really weren't being presented them. If you don't get enough ratings, if you put your show on Thursday night at 8 p.m. and you don't get X amount of number of people watching, the studio loses interest. The people that produce it start looking at other jobs, and well, this one isn't going to work, and they start moving on. And that's just the reality of television. And I think that with the internet, people are able to look at some of these subjects and someone will send out a tweet or a Facebook link or something like that, and then you'll say, whoa, this got 1 million people to look at it over the last 12 weeks. And this has sort of, instead of having this immediate time frame where everybody has to pay attention or the show dies, now ideas are allowed to sort of grow.
Yeah, I think you're absolutely right about that. I think we, as a culture, underestimate people. I think this is what you found with your podcast. I think there are millions of people out there who are interested in ideas, interested in the latest things we found out about the universe and nature and the way that it works. And they'll come to it. You build an audience, I suppose.
Yes.
Don't you? It's very important for the reasons that I outlined. Our civilization, Carl Sagan always used to say this, our civilization is based on science and technology. And so in democracies, if your democracy is going to function properly, then people need to know about the cutting-edge discoveries and the things that we've found out, which form the basis of our civilization. Otherwise, how can your democracy function properly? So that's partly the responsibility of the education system, of course. But I see, actually, the media on the internet and actually on television and radio as part of the education system. Now, I know that the media doesn't see itself as that often. It sees itself as a corporate effort to generate money for shareholders. But I criticise that quite strongly, actually. We're fortunate in Britain that we've got the BBC, whose job it is to be part of the education system, and it is a national institution. So having a strong public service broadcaster, I think, is one of the best things you can do as a country. I mean, imagine America. I know it would be anathema to the big corporations who run the TV channels, but imagine you had a channel which really had a lot of money. The BBC is well funded, that everybody contributed to in the States, whose job it was to act in the interests of the nation, whose job it was to say, well, we're going to make these big science documentaries and put them on. And yeah, we'll make entertainment shows and drama shows as well. We're going to make them because we think people need to know this stuff. We want to enthuse the next generation of scientists and engineers. That's important, actually. It's important not to expose people continually to drivel, basically, populist drivel. Because people, I think you're right, people want to think. I really believe that. People are interested. I rarely go into, a bar or a restaurant or a party and people say, what do you do? And if I say, well, I work at the Large Hadron Collider at CERN in Geneva. We recreate the conditions that were present less than a billionth of a second after the Big Bang. It's very rare that someone just says, yeah, whatever, and then goes and talks to somebody else. They're interested.
Sure.
So I think and maybe you're right. The optimistic view, as you say, is that the internet will remove this corporate layer of middle management in a way. This kind of the television executive. Maybe if you can remove that filter, which is like a sort of a malfunctioning kidney in the flow of information, then maybe it's a good thing.
In a way, it is. It's really kind of an archaic idea. The idea that at Thursday night at 8 o'clock, that's when the show airs. It airs for an hour. Well, now you can of course DVR things, and you can of course there's a lot of television shows have things on demand, so you can download them later. But I think that's the model. The model is the distribution through the internet, and this idea of sending things through the satellites and all the way they're doing it now with television networks. It's like. It's not going to work. It's not going to last. As soon as companies like Netflix and now Amazon is creating their own television shows as well, those are internet-based companies, and they truly understand what the internet is all about. And when Amazon, or rather when Netflix releases a series, they release the entire series. You can download like all 10 episodes. You can binge watch them, which is a great way to get people hooked on shows as well.
Yeah.
It's like this idea that, you know, the only way you're going to watch something is if it's on NBC or CBS or ABC, and then those people that run those networks, they're in a panic because they got to get people to watch, so they'll throw on some reality show about housewives that are fighting to the death, and people tune in. I mean, I hosted Fear Factor. You know, I understand what they're doing. I was a part of the problem or part of the solution if that's what you wanted to watch on television.
Yeah.
You know, they're just trying to get by. Like, they're just trying to figure out what's the next American Idol, what's the next, you know, whatever show, The Voice. Like, what do I have to do to get 18 million people to sit in front and watch a ball being passed from one man to the other and then try to get across the line? Everybody goes crazy. This idea that that's the only way we can get our information, the only way you're going to get entertainment or anything that's coming at you that's being produced and created, that's dead.
What I find interesting about this debate, though, is that the media is obviously tremendously powerful. It's obviously the interface between most people and ideas, and so I worry about the increase of choice in a sense. So it's a very good thing in some respects, but in other respects, what happens? You can ghettoize audiences, or audiences will become ghettoized. So let's say that, for example, I'm interested in playing computer games. So as a 17-year-old or something, if that's what you're into, you can just watch that 24/7. So you're not exposed to new ideas. So I would say, is that choice really? Choice is really what you mean is informed choice. So you mean, well, here's the spread of ideas that our culture has generated over, you know, more than 3,000 years of civilization. You will stumble across things you didn't know about. Maybe you become interested in ancient Egypt. Maybe you could become interested in the evolution of Homo sapiens in the Rift Valley 200,000 years ago. Maybe you find that fascinating. But if you're not exposed to those ideas at all, and culture has no way of exposing you to those ideas beyond the education system, then we have a problem. So I don't know what the solution is to this, but I think that there's something to be said. It will never come back now, but the old-fashioned model that we had in Britain for many years, where the BBC was really quite dominant, was that you could say, well, we're going to put X Factor on, let's say, or Dancing with the Stars, or whatever that thing is, and then after it, we're going to put a documentary on about astronomy. And the idea is that some of the people who were watching the talent show will drift into the documentary. Go, I didn't know I was interested in the moon of Jupiter called Europa that has an ocean surrounding it that may have life on it. I didn't know that. I didn't know I was interested. And that model works. So you're right, though, it's gone probably. So I think the great challenge is how do you expose people to new ideas in our culture? How do you get debates going? How do you stimulate that kind of excitement about knowledge in this new media world? Maybe you know, but
you're sort of an evangelist in that sense. Then I don't mean it in a religious way. I mean you're someone who evangelizes about the ideas of science and of space. Like, you think it's very important to spread these ideas. And that 17-year-old kid who watches video games all day, which easily could have been me, that kid will never break out of that mold. I think that the 17-year-old kid, if he really is completely obsessed and he wants to watch video games all day, the only thing that's going to fix that is he's going to eventually get bored, and he's going to want to try something new. And having the infinite options that are available today, someone could send him a text, dude, 3 words, infinite monkey cage.
Yeah.
Google it. And he'll be, all right, shit, I'm bored with video games. And then he'll have access to all kinds of shit that, like, if he was just waiting for the BBC to spoon feed him, he's never going to do.
Yeah.
Like, also, I think that having the stupid shows that we have here in America, like, if you watch reality shows, one of the things that you'll notice is the anger that people have about these shows. The anger that they're being force-fed this fucking stupid shit, but they're still watching it. That anger, sometimes that rejection of it, almost in your soul, forces people to go explore other ideas, or it inspires people to go explore other ideas.
It's an interesting model, isn't it? Frustrate them to the point
Yes.
of just absolutely. So you get so angry about the anodyne, soul-crushing, what's the word? dullness
Yeah.
of culture that you go seek out knowledge. Maybe that is a model.
I think there's something to it, man, because one time I was in my hotel room and I was watching Keeping Up with the Kardashians. And, look, it was in between shows, like, just flipping through the channels, and it was on. And it was like, I'm shopping and I can't find what I want to get. This is so frustrating. And my sister won't stop bothering me. And they're like texting each other. And it's so fucking mind-numbing. And somehow or another, I'm sucked into it. Like it's a tornado and it's carrying me away up into the sky. And then I change the next channel and it's some biology thing on crocodiles. And it's instantly fascinating. And it's these people that live on the Nile, and this scientist who's down there, and he's studying these crocodiles, and, there's the villagers who are worried about these things eating them. And then I'm thinking, wow, this is so fucking fascinating. These people are living next to dinosaurs. I mean, they have a real issue with dinosaurs eating their family. Or you could watch these just simple apes talk about shiny things, and they'll talk about shiny things for a whole, and millions of fucking people do. But the anger of can't take this anymore, and then you switch the channel or go online. I really think there's a yin and a yang to the world.
This is the strongest case for the Kardashians I've ever heard. That it compresses your very soul and existence just into such a small space that you burst out into a world of ideas. So that's. Yeah.
Well, it's analogous to California, because in California, we have too much sun. We have so much sun that it doesn't rain. We need 11 trillion gallons of water just to make up for the water that didn't rain in the last 3 years. It's a fucking disaster. But if you lived in a place like Alaska in the winter where there's no fucking sun at all and just looking for little peaks in the clouds, or those days in Portland where it's just 39 days in a row, there's no fucking sun. You just get crazy. You can't take it anymore. And then one day that sun is there and you're like, it's so beautiful. It's amazing. Whereas in LA, we're like, fucking sun. We're so tired of the sun. People get used to shit.
I'm going to call it the Rogan model, which is just depress everyone to the point of the Rogan model for broadcasting.
Yeah, bore the fuck out of them,
and they'll surely at some point.
And then put the Cosmos on.
There must be more to life.
Yes, and then when it comes on,
mechanics textbook.
And then they get it. Well, not everyone. There's going to be some people that are always going to be. They're going to always gravitate towards nonsense. There's nothing you can do about that. It's just we're so varied. We're so the spectrum of human beings, from the smartest to the dumbest, is so wide. There's no getting around that. Life experiences, genetics, whatever causes it, I don't know. But there's just certain people that do not give a fuck, and they're gonna always be there. But concentrating on them, and like, it's profitable. Like, you could sell them shit. It's a really good model if you're in the business.
It is. You said earlier that I'm perhaps optimistic, but I think we can sell them. It sounds almost them, this group.
Some of them, yeah.
You could sell. I still think you can sell ideas to people. I'm going to be optimistic about it.
Those people maybe not, but there's a lot of fucking people. There's 350 million people in this country alone.
We underestimate people, I think. I've rarely met someone who wasn't interested.
Oh, let me take you around.
Are you going to?
Let me take you around. Let me bring around some dummies. Listen, dude, there's some fucking dummies out there. There's a lot of smart folks like yourself. You're hanging out at CERN, a bunch of other physicists. You're talking about black holes and shit.
There might be a selection effect. You're right. You might say. I've never been into the cafeteria at CERN and met anyone who's not interested.
Trust me, man. I hosted Fear Factor for 6 years, and I'm a cage fighting commentator. There's dummies out there. There's unfixable dummies. And it's probably not their fault, but it's probably one of the greatest pieces of evidence that points towards natural selection and points towards the variability of life, in that human beings, we vary so strongly that in comparison to other like wild animals. If you see wolves, you see wolves that are slightly larger and slightly more dominant, and wolves that are slightly smaller and slightly more timid, and they get pushed out of the pack. But they're all fucking wolves. You see people, and you see Brian Cox, and then you see Kim Kardashian. I mean, you guys are both on the same timeline. You're both alive in this point in history, and one of you is talking about fucking shoes, and the other one is trying to figure out what happened right after the Big Bang. And one of them has a fuckload more people paying attention, Brian Cox, and it ain't you, buddy.
Well,
it's that chick. The chick with the fake ass is the one who's getting all the eyeballs.
Going back to Carl Sagan's great book, The Demon Haunted World.
Great book. I love that book.
I mean, he makes the point that the thing is, these people, everyone has a vote. And rightly so. We live in a democracy right now. You might say, well, could we have some kind of IQ test threshold for the vote? But therefore, the direction of our societies is, in principle, in the hands of everyone. So we can't just accept the fact that, well, all right, well, 1% of the world's population is going to pay attention to reality, and the rest of them are going to pay attention to reality TV, and we're going to be okay. We're not going to be okay because the 99% will be unaware what they're voting for. That they have control, and rightly so. We live in it over the direction of our countries. So education is extremely important. It is important for people for us to try and make available the great swathe of knowledge that we've accumulated over the last.
We were absolutely in agreement about that. I just think that the open nature of the internet enhances that more than stifles it. I think there's only good. I only see good. I think I'm a big fan of old shit. I love to go watch old television shows and old movies and especially old stand-up comedy performances. Because there's not just because it's sort of like a time machine. You're looking back at this moment that's been captured, which is absolutely fascinating to me, but also the stark differences, the obvious differences between culture then and culture now, between the awareness of the people that, like, there's some movies that were really good movies, but if you try to watch them today, you go, oh, who's that fucking dumb today? Like, no one is that dumb today. It's hard. Like, the education level of the people that are communicating in these movies, the way they view life is very obviously different than the way we view life today. Like, you could not put Father Knows Best on television today because people wouldn't they're not like, not enough. Nope, it's gotta go to a higher frequency because human beings are very different today than they were in 1950. I think our culture is one of the clearest influences. There's some amazing stuff from 1950. There's amazing books that were written. There's amazing films that were made. But the reality is the culture has shifted dramatically in the last 64 years. There's no getting around that. It's changing. And I think having something like the internet just pushes that in a direction. And a guy like you who gets upset at all these reality shows, it's really just proof that this is what you're designed to do. You're like designed to educate. Like these people that are annoying you and these programs that are stupid, that's actually just fuel. It's just giving you more. It's giving you an adversary. It's giving you motivation to stop it from happening. I mean, if everybody was going to college and everybody was super educated and really aware of the problems with plastic and fossil fuels, and boy, what a weird world we'd live in. Probably nothing would ever get done. Like the battle between the dummies and the people like yourself is essential. It's essential. It's the yin and yang.
The idea that the thesis, the defining, the motor of civilization and human advancement is irritation with dumb people.
I think it is. I don't appreciate naps unless I work out hard. I don't appreciate vacations unless I'm just exhausted. I have to be exhausted with work to appreciate vacations.
I must say, it's one of the threads. I mean, we started talking about Infinite Monkey Cage. It's one of the threads through the whole series is a slight annoyance that we turn into something that's interesting. It generates ideas for us. I mean, we had a letter about the title, The Infinite Monkey Cage, complaining, and
you shouldn't cage monkeys.
No, that was it. It was like, it's cruel. It's cruel. And it's an infinite cage. It's roomy. It's a lot of room. It's arguably the universe is an infinite cage. And then another letter came in. I think it might have been a response. So we'd sent that back, and they said, it's also supporting this kind of Darwinian myth, the Darwinian myth that we somehow share a common ancestor with a monkey. So how so? And he said, well, there was an experiment done that disproved all your nonsense. So we like experiments, we like evidence. So this is really interesting. What's the evidence? So we read down, and they said there was an experiment done in a zoo in Alabama or somewhere where they got 10 monkeys and they gave them typewriters, and after a week, all they'd done was shit on them. So the idea that an infinite number of monkeys could write Shakespeare and all this is a myth. And it's like, well, there's a difference between 10 monkeys and an infinite number of monkeys. It's not, 10 is not very close to infinity. And it's just these complaints about my friend Robin Ince, who I co-present it with, he said it's not an incremental process, this kind of infinite monkey thing. It's not like if you have 100 monkeys, then eventually they'll produce a leaflet. And then if you have 1,000, they'll do maybe a book, and then if you had 10,000, they'll do Shakespeare. And it's not, really we mean it. It's an infinite number of monkeys you need to type out the works of Shakespeare. But yeah, we enjoy the complaints. We get a lot of complaints from Deepak Chopra actually these days.
He's a silly bitch. Isn't
like
that one of those things that's like one of those expressions that people always use? That if you take an infinite number of monkeys and give them typewriters, they'll type out Shakespeare, the works of Shakespeare. Is that true?
Well, it is true. It's an infinite number of monkeys.
Yeah, but even an infinite number, I think they're going to fail. They're going to fuck it up.
No,
they're monkeys.
You don't think? No.
They're still monkeys.
You were talking to me earlier about infinity.
I know, but if you get an infinite number of monkeys, if there's the same animal, they're the same exact animal, they're going to type the exact works of Shakespeare?
Well, they will, because there's an infinite number of them. So every possible combination of letterpresses must happen.
That is true, but would it happen? What is the odds of it happening in the exact same order of the works of Shakespeare? Is it even calculable?
Less than zero.
Less than zero. But it's still possible. Greater than
the
zero.
odds are greater than zero. So that's the point. So if you've got an infinite number of them, and then you will get everything that can possibly happen will happen.
Could you imagine if one monkey just randomly, they gave it a key, look, we're talking about the entire universe, right? So we're talking about an infinite number. But what if they just get lucky as fuck and give one monkey a typewriter, and this little dude just starts banging out the entire works of Shakespeare, but he's still a monkey. He's still like playing with his butt and, swinging around and having a good time. He's not doing anything else other than when they put him in front of this keyboard, he types out all the works of Shakespeare in exactly the right order, with the exact punctuation, the exact spaces in between letters.
Well, if the universe is infinite, which it may well be, in fact, there are many ways the universe can be infinite, then that would happen. Because everything, if it's in accord with the laws of physics, then it can happen. And everything that can happen in an infinite universe will happen, because the universe is formally infinite. So I contend, and we'll probably get emails about it, but I'm trying to think whether there's any counter-argument. I don't think there is. I contend that in an infinite universe, even the most unlikely possibility must happen. In fact, formally, an infinite number of times. So maybe Shakespeare was
a monkey.
Actually just looking.
Yeah, maybe it was someone's pet monkey.
We could calculate it. We could calculate it. Someone can do it online now, because there are, how many letters are there in Shakespeare, the complete works of Shakespeare? So you can Google that, someone will tell you. And we know you've got 26 possibilities, and so off we go. And so what's the probability? What are the odds of randomly typing on a typewriter, let's say at 1 letter per second? How long will it take, and what are the odds that you'll type out the complete works of Shakespeare? That's a known number. I don't know it off the top of my head, but it can be calculated. So that's my challenge to your viewers and listeners. Send in that email. Someone will do it. There'll be someone working at MIT or something who can do it in 5 minutes. That's an easy sum.
And then you would have to calculate how many monkeys start out with Romeo and Juliet and then just start shitting on their typewriter. They start out.
I know the answer to that is more than the other one.
And how many get the first chapter perfect and then just shit all over the place?
No, right, all the way to the last word, the last single digit.
Well, I bet every keystroke along the way, there's a monkey shitting on their typewriter. Like you get the first paragraph, shit all over the place. This guy got to the second paragraph, shit all over the place.
Yeah, and to go back to our infinite monkey cage complaint letter, that proves that Darwin's wrong. That's the logic.
Yeah.
Can I just say that if someone doesn't remember, I just came into the podcast at that point.
Oh, he doesn't. Yeah, you can't cherry pick that quote. Yeah, Brian Cox does not think Darwin's wrong.
That'll be in the press.
There's a great website, a Twitter handle called Take That Darwin, where people that are educationally challenged will question Darwin's theories. Like my favorite one is, if people came from monkeys, how come monkeys are still around? Like they retweet that all day because someone says that.
Fundamental misunderstanding of evolution. that really is. You're going, right, where am I going to start here? Maybe with a book.
The only way to truly test is to, I think what we really need to do is take monkeys and give them psychedelic drugs. We need to do this. Someone needs to do this. They need to take an island where the monkeys can't escape and give them psychedelic drugs and leave them puzzles and see what they figure out.
Why does that test anything? It's just fun, isn't it?
Doesn't.
You just think it's
It doesn't. It would just be fun to watch.
Yeah.
There is a guy named Terence McKenna, who I'm a huge fan of, who had a theory called the stoned ape theory, and he backed it up allegedly. Remember who this is coming from, with climatological data on that time of the world, that he believes that the evolution of human beings, the big part of it, the development of the human brain, might have come from them experimenting with psychedelic mushrooms. That as the rainforest receded into grasslands, animals were forced to try new foods out because their habitat was changing, and they would climb down for these trees and flip over these cow patties to get bugs and worms and things along those lines, and that this time of the world, it was very common to have these psilocybin mushrooms growing all over the place, and that the monkeys that would eat them, he had a bunch of theories like, apparently it's been proven that in low doses, psilocybin increases visual acuity, which would make you able to see things better, which would make you a better hunter. Also makes you horny, so it would make people more likely to breed. And that would favor the people, or the monkeys rather, the subhuman primates, whatever you call them, that went along that line.
Well, it is one of the more widely accepted theories about hominin evolution, as they call it, is that climate change played a key role. And actually, there's in my latest series, Human Universe, we focused on a theory which links the climate change, particularly in the Rift Valley, because we know that the big jumps in brain size all occurred in the Rift Valley of Africa, and it's quite remarkable, actually. And that's broadly speaking accepted, I think, although there's a lot of argument with anthropologists because the data is sparse, but it's broadly accepted that. And it seems that the big jumps in brain size occurred at times when the Earth's orbit was most elliptical. So the Earth's orbit oscillates, it becomes more elliptical and more circular, and there are many different oscillations driven by gravitational interaction with the planets, like Jupiter in particular. And it seems like when the Earth's orbit's most elliptical, the rate of climate change in the Rift Valley is higher and more extreme. And it seems to be the case that there's relatively strong evidence for the case that when you get these really rapid times of climate change, as you mentioned, then you get increases in hominin brain size, and therefore increases in intelligence. There's a big one 1.8 million years ago, which was a very big increase in the number of species in the Rift Valley, of which Homo erectus was one of them, which eventually led to us, and a big jump in brain size as well. And this was at a time when there's strong evidence for rapid climate change in that region.
So that makes sense, like the adaptability of these animals, experimenting with new food sources, trying out new hunting methods. A lot of them changed from herbivore to omnivore, a lot of the primates that were observed, right?
Well, that's where it gets controversial when you look at the academic research, because the sort of Darwinian idea that so you get this pressure from climate change, but then what's the selection effect? Because climate change happens over many generations, it doesn't happen over one generation. So the question is, well, what actually is doing the selecting? What are we selecting for? Why is this group more likely to breed and be more successful if it's more intelligent? So some people say, well, it's because they were forced into groups. So it's group dynamics. It's the fact that you end up with bigger tribes, hundreds of individuals cooperating together, and that's what's been selected for, and you need to be intelligent for that. Some people say, as you said, that it's adaptability. So maybe they have to learn to go fishing, or they have to learn to eat particular different crops, and then maybe that's
right.
So that's a big area of debate about what might have been the selection pressure, this precise selection pressure. But it does seem pretty nailed down that climate change, certainly in that region of Africa, in Ethiopia and Tanzania and through the Rift Valley, had played a role in driving us towards intelligence. And it's interesting that the time scale is very small, by the way. I mean, so you go back 4 million years, and things like Australopithecus are around, which are basically upright chimpanzees. The brain is not much bigger than a modern-day chimp. But then you go to 200,000 years ago, and that's when Homo sapiens first emerged, just over 200,000 years, which is not very long ago. And it's quite remarkable, actually. And the modern theory is they spread out of Africa about 60,000 years ago, and they made it into Europe about 43,000 years ago or so, into North America and South America only 15,000 years ago. So it's quite a rapid spread. And the fact that we've only been around as a species for at most 250,000 years, 250,000 years is quite remarkable, I think.
Well, when you think about what we've accomplished, I was flying into Los Angeles last night, and I was thinking, if you could take the pioneers that came from Europe in the 17 and 1800s, the guys who were on those wagons with the wooden wheels, and they're pulling them with horses across the country trying to see what's over there. If you could show them, like, hey man, this is what's going to go down in 2015. Hop on this plane, look out this fucking window.
Yes.
Whoa, look at that grid. They would freak the fuck out. They saw all the electricity. That's like the sky of Los Angeles. In my opinion, Los Angeles is more beautiful at night than any other city because it's so spread out.
Yeah.
It's all lights. As you're flying in, it looks so science fiction.
Well, you know, I recently interviewed the astronaut Charlie Duke, who landed on the moon, one of the Apollo astronauts. And he said to me his father couldn't believe it because he was alive when the Wright brothers flew. Wow. So his father spanned the time from the Wright brothers, and he was alive. And then his son walked on the moon in one lifetime. 60 years, well, 70 years.
Well, the real mind fuck is with the creation of the plane to the time someone dropped an atomic bomb from the plane is less than 50 years.
Yeah, and in nuclear physics, we didn't know. We didn't know there was an atomic... Rutherford discovered the atomic nucleus in Manchester in, was it 1912 or so? I should know. But anyway, something like 1912, 1913. So he discovers the nucleus. And within 30 years, you have an atomic bomb. I didn't even know. And Rutherford was actually asked at the time, he said, so it's the usual question we get as physicists. They say, what's the use of this? And Rutherford said that there's no use to it. He said, anyone who thinks that you could use this as an energy source is talking moonshine. And within 30 or 40 years, you have nuclear reactors producing power and you have atomic bombs.
Wow.
Rapid progress.
Well, that's one thing that's been constant about people and predicting the future. We've always got it wrong. Always.
Yeah, we miss some of the rapid advances. You know, we talk about, there's a computer there and a phone here. The fact that in modern electronics is a single lifetime. The transistor is 1940s, I think, at Bell Labs here in the US. It's not long ago, that you go from that to this. I mean, we talked about the Apollo. I mean, this is significantly more powerful than anything that was available in the world when Apollo was there. The rooms filled of computers at NASA, which were nowhere near as powerful as that.
It's amazing. I mean, that's those Google glasses that people are wearing is a sign of things to come, in my opinion. They stopped making them, but there's a new company that has like a goggle that looks like a skiing goggle, and it allows you to move things in front of you like a virtual desktop. You can spin squares, hold things in place, throw things to the side, and they disappear. I mean, we're going to get really, really, really weird within the next couple of decades.
Yeah, I've actually seen some of that technology. There's a company called Magic Leap. I've been there in Miami.
You saw it in person?
Yeah.
What does it look like?
Really, it does indeed. You can put 3D objects into your field of vision. So
how is that working? So you've actually seen it.
I signed an NDA.
You did? You can't talk?
Yeah, but I tell you that it works. It's a remarkable thing.
Damn.
I think Google have just bought the company, actually.
We played it. We played some videos of it, and we couldn't figure out whether we were watching a simulation, we were watching what the future holds, or we're watching an actual demonstration of that technology.
Yeah. Oh, it's going to be impressive, I think. And it's interesting what you said because it brings the web, this unlimited information into your field of vision, so you can manipulate it. And then there are questions about what's real and what isn't, and who cares anyway. Really. And it's an interesting.
Do you dabble at all in the theory of some sort of an artificial world that we live in? These ideas of simulation. Do you dabble in that, or is it just too much?
It's interesting, actually. I mean, a colleague of mine at Manchester, there are some physicists who think that it's a possibility, a strong possibility that we're living in a simulation. I mean, it's speculative out there stuff, but it's an attempt to explain some properties of the universe that are interesting and unusual. So one of my favourite, I think, at the moment, piece of cutting-edge physics, in cosmology. Cosmology, I should say, the study of the universe, the origin and evolution of the universe, is going through a revolution at the moment, and it's coming from data. So it's coming from measurements of things like the cosmic microwave background radiation, which is the oldest light in the universe. We're making it, so just to rewind and say what that is, 380,000 years after the Big Bang, the universe became transparent for the first time to light. And that's because it was cooling down. As it was expanding and cooling, then atoms formed. It became cool enough for atoms to form. And at that moment, very, very quickly, the universe becomes transparent, and so photons of light can travel on through the universe, and they've been doing so ever since. And we can take a photograph of that, and we have done, with a series of satellites, the most recent of which is called Planck, which is a European satellite that's up there. So this is a picture, a baby picture of the universe, as it was 380,000 years after the Big Bang. It's a very beautiful picture. But in explaining that, that's given support to theories called inflationary cosmology theories. So inflationary cosmology theories say that before the universe was hot and dense, which we tend to call the Big Bang, before that the universe was still there, and it was doing something else, which was an exponential expansion. So it was expanding exponentially fast, way faster than the speed of light. Then it stops, and all the energy that's causing that expansion gets dumped into space, heats it up, and that's what we see as the particles and energy today. So those theories are kind of interesting. But they also suggest that there are theories called eternal inflation theories that say, well, how long did that period of expansion go on for? And does it all stop at once, or does it stop in patches? And if it stops in patches, if it stops in a little patch, you'd get a Big Bang and a universe. And if it stops in another patch, you get another Big Bang and another universe. So these theories suggest perhaps there are an infinite number, possibly, of Big Bangs, in inverted commas, which would mean there are an infinite number of universes like ours, and they're being created now, all the time, and they will continue to be created forever. So you get this fractal multiverse, ever growing exponentially fast. And really bizarrely, those theories have some support from the cosmic microwave background. They're theories that explain the structures we see. I should just underline the fact that this is speculative in a sense, but it's relatively mainstream. What one of my colleagues noticed, and some physicists have noticed, is if you were some kind of omnipotent deity programmer, and you wanted to run what's called a Monte Carlo simulation to say, well, I'll vary the strength of gravity in one universe and vary the mass of the electron in another one and vary these physical constants and see what happens, then this is probably the kind of thing you'd do. This is what it would kind of look like. So that you can make an argument that the universe, in some sense, looks like one of these kind of so-called Monte Carlo simulations, because it gives you the possibility of generating every possible number of different ratios of the strengths of the forces of nature and all these things. But I just have to emphasize, this is way out there, on the edge. But it's fun. And what is fun and interesting, though, is that the wind all the way back, the inflationary cosmology bit is probably the most widely accepted theory at the moment for how the universe got to be the way it is. And it does lend itself to this idea that there may be a multiverse. And it may be that in each different pocket universe, if you like, you can have different physical constants. So most of them wouldn't allow life to exist, but some of them would. So our universe looks very fine-tuned if you look at it, in a sense. It looks like the laws of nature were very slightly different. You wouldn't get carbon, for example, produced in stars in large quantities, which you need in order to... And when the stars die, the carbon and the oxygen come out and they relapse into another generation of stars and solar systems, and that's how you get the heavy elements that make up our bodies. And so all those things look... You either try and find an explanation for why the laws of nature are the way they are, or... You go to one of these multiverse theories and say, well, actually, it goes back to what we were talking about earlier about the infinite monkeys. And actually, every possibility occurs in nature. And then we shouldn't be surprised that we live in a universe that seems fine-tuned for life, seems perfect for us to exist in, because every possible combination of the laws of nature exists somewhere. And this is where cosmology is at the moment. This is genuine. You could go onto the web and Google it. You'll find a 1,000 review papers on what's called inflationary cosmology, and it is cool and interesting, actually.
Yeah, it's beyond that. It's very... The idea of something being infinite and not just infinite, but infinite numbers of these infinite things.
Infinite numbers of infinite universes. These theories exist.
So this idea of computer simulation, the idea that the world we live in, the universe we live in, is a simulation.
But that was the question that you first asked.
Well, it's no. It's because what you went on is beautiful. Don't change the thing. You stay you. The idea being that one day, if human beings continue to increase our technological abilities, one day we're talking about this magic leap, and we're talking about the goggles that allow you to see a virtual world. We're going to, if we don't blow ourselves up or get hit by an asteroid, we're going to come up with something that is indistinguishable from the reality that we see right now. And when people start examining the nature of the universe and they start looking at the fractal nature of things and looking at, like what you were saying, that if you were going to be some omnipotent deity that creates the universe, you'd probably do something like this, like every single combination and throw them out there. So when we discover, like is James Gates, that was the guy's name? Sylvester Gates. It was a guy who spoke to Neil deGrasse Tyson about string theory, and that they found in string theory this computer code that was created by humans in like the 1930s. They figured this out, and that this actually exists in these codes in string theory. And his idea was that somehow or another proves that there is some evidence support that life, the reality that we see right now, is a simulation. Or it could be that, which way more likely, that you're just discovering some sort of code that the entire universe is based on. That when you look at things being fractal and you look at the idea of there being not just infinite expansion but infinite contraction, and that there is no smallest point, there's just smaller than we can measure. But when we talk about subatomic particles and we talk about things being like atoms being mostly air, and then you go deeper and deeper and you don't know what the fuck is going on, and particles are blinking in and out of existence and existing at the same time, both moving and still. But could it be that you just got to keep getting, we just can't see it?
Well, the answer is, we sort of do know what the fuck's going on at some level with subatomic particles.
Right.
If you look to the LHC, which is the Large Hadron Collider, which is the place where we generate the highest energies, so it's the biggest microscope in the world in that sense. We have an extremely good understanding of the laws of physics at that level. Up to and including the discovery of the Higgs particle.
That's been proven? Is that in the debate at all? The Higgs? Because I remember there was some people that were debating whether or not the Higgs... How do you say boson? Do you say boson?
Yeah, boson. There is a particle there that we've discovered, and it has all the right properties to be the predicted standard model Higgs particle.
Please explain what that means.
So the Higgs particle, it was predicted back in the 60s by Peter Higgs and others, hence its name. And it's the idea is basically that early on in the expansion history of the universe, so let's say less than a billionth of a second after the Big Bang, as the universe cooled, it went through something condensed out into empty space. So people call it a phase transition, but it's analogous to a window pane on a cold winter's day. You don't have cold winter's days in LA, do you? But imagine somewhere else.
It gets 50 degrees.
Yeah. If you were to get ice on a window, it's analogous to water vapor condensing out into ice. As you drop the temperature, it changes into something else, into ice. So in the same way that the theory is that as the universe cooled, something condensed out. So empty space isn't empty. It's full of Higgs particles, if you like, or a Higgs field. Wow. So this means this space. Now, it's not just space between the galaxies. It's in this room that every square meter of this room is full of the Higgs field. And our fundamental particles, the electrons, let's say, in our bodies, interact with that Higgs field. And in that process, they acquire mass. So it's the mass generation mechanism. It's why some particles are massive, like electrons and quarks, and some things like photons are not massive. They're massless, and they travel through the universe at the speed of light. So that's the theory. Now, that was suggested and built mathematically, essentially. There was very little evidence for it at the time, back in the 60s. But over the years, the theory, called the Standard Model of Particle Physics, passed all experimental tests. So we got to the point where we thought, right, okay, we will build a machine that will either disprove or prove that theory, and the LHC is such a machine. If that theory is correct, which it now seems to be, the prediction is you must find the Higgs particle at the LHC, or some kind of Higgs particle. And indeed, we found it. as far as we can tell. So that means that we found a new particle. It has the right mass as predicted in the window that was predicted by the theory. It behaves in every way like the theory predicts. So now what we have to do is be experimental physicists. So the LHC turns back on again in about a month, actually. So it's been upgraded, it's been fixed, and it's done its maintenance. So we're going to make more Higgs particles now, and that means we can make more precision measurements and find out whether it is the particle predicted by Peter Higgs, or maybe it's one of a number of Higgs particles, just possibly. It's likely not now, but it might be. So there might be 5 of them, for example, which would suggest that theories called supersymmetric theories are right. So we need to know exactly precisely how the thing behaves, which is why we have more work to do. But it looks like it's very sure that it is a Higgs particle. You can mess around and build esoteric theories that get you around it, but there is a new particle there. There's no doubt about that, and it looks like one of these things. But that's a remarkable thing to think about it, because it's Wigner, a great physicist, wrote an essay back in the 60s, I think, called The Unreasonable Effectiveness of Mathematics in the Physical Sciences. And by the unreasonable effectiveness is demonstrated by this discovery, because it really is a mathematical prediction. It's like we think there's a new fundamental particle that does the job of giving mass to the other particles. And this is how it does it, and this is how it behaves, and this is what it will look like, and this is what it will do. And then 50 years later, you build the biggest machine ever built, 16 miles in circumference. Most of it's in France, a bit of it's in Switzerland.
10,000 scientists, 150 countries.
You accelerate protons, the nuclei of hydrogen, around this thing at 99.99999% the speed of light. They go around the 16 miles 11,000 times a second. We can collide 600 million of them together every second to recreate the conditions that were present less than a billionth of a second after the universe began. Photograph it in the biggest digital cameras ever built. The one I work on called Atlas is 40 meters in diameter. Huge, vast thing. 7,000 tons of digital camera in a cavern the side of St. Paul's Cathedral underneath the ground in Switzerland. And you find it. You find this thing that this guy, Peter Higgs, working with many other people, predicted to exist 50 years ago because he did some sums. And so it's real. So the universe does behave like that. There is a condensate in the vacuum. It is a Higgs condensate. It does give mass to the other particles. So it's a tremendous testament to the power of human reasoning, I think. And it means that we understand physics. It means that that's one of the important things about it. It means that our understanding of fundamental physics is not horribly wrong at the moment. It's good enough to predict something like that, which is a remarkable achievement.
That is mind-blowing. That is truly mind-blowing.
And do you know when Peter Higgs actually, the day that the discovery was announced at CERN, packed auditorium, and Peter was there, and a journalist went up to him afterwards, and just what I've said, this is what happened, this machine did it, he found this thing, and they said, how do you feel, Professor Higgs? And he said, it's very nice to be right sometimes. That's what he said. Brilliant, understated.
That's about as much.
Is
he British?
Yes, he is.
There you go. That's exactly how a British guy would behave.
A cup of tea.
American would show up with a fur coat on, with diamonds around his glasses. We have a big pimp cane.
And then someone had come on and said, you should have given the Nobel Prize to Beyonce, because it's just not fair. This and what was that? I saw that at the Grammys last night, wasn't it? Was it who was it? It was Kanye West, wasn't it, who keeps jumping on stage? And
saying, he jumped on stage once, right?
Yeah.
He didn't do it again last night, did he?
Apparently, didn't he?
Almost.
He walked off.
Did he have a go? He said at Beck.
I can't be bothered.
So I just keep thinking.
See, you're part of the problem. You just went and talked about Kanye West in the middle of one of the most mind-blowing discussions. He is.
I call that other guy JZ, and someone said not JZ.
Well, it's because you call ZZ.
I know, yeah.
That's
so
a British thing. Like, people don't know, like the Z06 is a type of Corvette. They call it Z06.
Yeah, so JZ was there anyway. JZ. That's my level of popular culture.
The Large Hadron Collider also figured out or proved quark gluon plasma.
Yeah, so that's later
explain that
in the universe, in the history of the universe. So way after the Higgs mechanism kicks in, you have a period when it's still too hot for protons and neutrons to form. So the building blocks of atomic nuclei are protons and neutrons. So a proton is made of 2 up quarks, or quarks, and a down quark, and a neutron is made of 2 downs and an up, and then some other stuff in there, gluons and things like that. But the universe went through a phase when it was too hot for that to happen. So you get this plasma, this sea of the free quarks and the gluons and all these things just before it gets cold enough to condense into protons and neutrons. And we investigate that by colliding heavier things than protons together at the LHC. So we can do silver atoms or silver nuclei or lead nuclei and things like that. The LHC can do that. And it produces this about a millionth of a second after the Big Bang, so quite a long time.
Quite a long time.
This is a lot has happened from that point.
Relatively
so we can
speaking.
do that as well and see how that phase of the universe behaved.
And that stuff is supposed to be just immeasurably heavy, right?
Oh, the atomic nuclei.
Yeah.
I mean, if you look at... So an astrophysical example would be a neutron star, which is basically a big nucleus, nuclear-dense material, the end point of a collapsed star when it's run out of fuel. If it's not too big. If it's too big, it'll turn into a black hole. So a neutron star would be 1.5 times the mass of the sun, let's say, something like that. But it would be a radius of 10 miles. So it would easily fit in the LA metropolitan area, right? But it would have the mass of the sun or greater. So that's an atomic nucleus density. That's how you can imagine it. Something as massive as the sun compressed into something 10 miles across. And we see these things all over the universe. Neutron stars are fascinating things. But,
Someone online was explaining it. Some physicist was explaining that if you had this quark gluon plasma and it was the size of a sugar cube, it was some ungodly amount of weight.
yeah, I
Like
mean,
you
it's
couldn't even imagine it.
Mount Everest, that kind of.
It would be like Mount Everest.
Yeah, I can't quite remember the number, but it's something enormous. It's like
You broke my brain.
well, if you think about it, all our mass is in. You alluded to it earlier. Our mass is in the nuclei, and if you got all our atomic nuclei, mining your nuclei and stuff them together into that density, it would be a grain of sand or something less size. So you could. I mean, you think about the universe. I mean, the modern theories of the Big Bang, we talked about earlier, these inflationary cosmology theories, they suggest that the entire observable universe, which has now got 350 billion galaxies in it, was at some point the size of a baseball or less. So we imagine, or we speak of, in modern physics, we have theories that address the time when the entire observable universe was something
That you could
big.
hold.
So you've got enough energy in there to make 350 billion galaxies, each with 200 billion stars. And it's remarkable that we're not quite there with the laws of physics, but we're not far. Those are the kind of, that's the physics we're doing at LHC. Basically, we're trying to explore the laws of nature and find the laws of nature will describe the universe when it was that hot and that dense. And we are quite close. As I say, we're good from about a billionth of a second after the Big Bang. Then that's where we have our theories that talk about the Higgs boson and things like that. And so we understand that very well. So the challenge now is to get back beyond that. And that's where string theory attempts to live, which you mentioned earlier. String theory, we don't know if it's right. We have no evidence that it's an approach to trying to describe the universe before those times when our current laws work.
The idea of a birth and a death of a universe troubles some people. The idea that we have sort of artificially subscribed, the idea that this had to start somewhere, and that it may very well be an infinite expansion and contraction, like waves going in and waves going out. The idea being that the entire universe may one day get to a point where it pulls down into itself and becomes one event horizon, one infinite piece of mass, and then starts all over again. Is that possible?
If you look at how the universe is expanding at the moment, then it is accelerating in its expansion. So the measurements tell us that the expansion rate itself is getting faster. And we have a name for that. We call it dark energy. So and of order 65-70% of the energy in the universe appears to be taken up in driving this increasingly fast expansion. And so that looks like, if nothing happens, then that becomes dominant. So it continues to accelerate in its expansion. And in the end, you get something that looks like this inflationary period that I said may have existed before the universe was hot and dense. So it looks like, so that looks like what's happening at the moment. So whether that can stop, whether there's something that can stop it in the same way as it seems to have stopped very early in the history, by the way. And whether that's true, nobody knows. We don't know the mechanism. But the measurements tell us of distant, particularly of looking at supernova in distant galaxies, and also actually from this cosmic microwave background radiation I mentioned earlier, the detailed modelling and measurements of that all are consistent and suggest that the universe is accelerating in its expansion. So that would suggest that it's not going to rebound, because it's like a big rip scenario almost, where everything's accelerated. Space-time is stretching at a faster and faster rate at the moment. That seems to be what's happening.
So you feel that it's much more likely that there are infinite numbers of these things happening, that there's not just one big bang that creates this universe and we're watching this universe expand, but that there's infinite numbers of these things that are happening at the exact same time?
That's more speculative. So the way that the inflation is probably textbook now. You get some physicists that will argue with it, but broadly speaking, I think many astrophysicists think that inflation's the best theory we have, because it makes predictions that agree with observation. So it's the best theory in terms of making the best predictions at the moment.
And this
so
is that it's
that
accelerating
that
in
a
its
very
expansion.
very fast, superluminal, faster than light expansion that stops, and the end point of that is what we used to call the Big Bang. So that's broadly speaking textbook stuff. That's what you teach in undergraduate cosmology courses. Then some physicists argue that the natural extension to those theories are theories called eternal inflation, which are what you said, where so this exponential expansion of space-time is always going on, and it stops just in little patches, and that little patch is where you generate a new pocket universe, if you like, of which ours is one example. And you can have an infinite number of those, and they would be being produced now. And you can ask the question, how long has that been going on? And the answer is nobody knows. And there's a debate, even amongst the people who believe in those theories, about whether it could have gone on forever, or whether it would have started in what a colleague of mine at Durham, Carlos Frank, calls the mother of all Big Bangs. So was there a mother of all Big Bangs that set this process in motion? And in that thing that got that big fractal thing, you get loads of little Big Bangs. And the answer is this is cutting-edge stuff. It's very exciting. But so I'd say, just to be very precise, the inflationary bit, the simple bit, which was first put forward in the 80s, actually, by Alan Guth and people like that in the US. Andre Linde, another one. That looks right in the sense that it matches data very well. And the consequences of it are argued about and are active areas of research at the moment.
One of the things that people were terrified of about the Large Hadron Collider is that in trying to find the Higgs, that you might accidentally create black holes, little tiny ones that would just go eating through the Earth like a little ping pong ball that shot through the entire planet. That's idiots like me that thought that would be possible.
Definitely shit. However,
but is it possible to create a Big Bang, or excuse me, a black hole? Is it possible theoretically to have enough power? Like if you don't have it right now with the Large Hadron Collider, is it possible that a larger machine will be created and human beings can recreate a black hole?
Yes, it's possible, yes. And it's possible if you have extra dimensions in the universe, right? So the thing is that we know gravity is a very weak force. It's by far the weakest of the four fundamental forces of nature. It's billions and billions of times weaker than the other ones, which you can tell because you can pick up, a phone, even though the planet Earth is trying to stop me doing that, and I can just resist the pull of planet Earth. So gravity is very weak. So that gives you a clue that you can say, well, at what energy, how far do I have to go back in time, if you like, towards the Big Bang, before it's so hot that gravity is as strong as the other forces? The strength of the forces varies, I should say, with energy. So they change. And we've seen this behaviour. So two of the forces, so-called electromagnetism, which is the most familiar one, electricity, that one, and the weak nuclear force, which is one of the forces that operates in the atomic nucleus, they are the same force. They're manifestations of the same force, and we've seen this experimentally. And in fact, the Higgs boson is part of that process. And so we've seen the energies that they become the same force. So the idea is the other force, the strong nuclear force, if you go to higher energies and temperatures, converges, and then you have some things called grand unified theories. And then gravity makes its lethargic way back and unifies with them at something called the Planck energy, which is immensely short timescales after the origin of the universe, if you want to. Very, very hot. So way in excess of anything. So if you just want to just create black holes in a lab, then the naive thing is you'd have to go to those energies, and there's nowhere in the universe you'd never do it. You'd have a particle accelerator the side of the observable universe, and it wouldn't be big enough.
Wow.
But if you allow extra dimensions in space, so you imagine that, so we would live in a three-dimensional space, and then there's time as well, so we've got 4 dimensions. If you allow there to be 5 or 6 or 13, I think the string theory, they keep changing their mind. But, there's
13 now?
Something like that. I don't know really. But they're all... Then what you can do is you can arrange for that energy scale at which gravity becomes important to come up, so the temperatures to drop. So you can arrange in some contrived way to get to the point where you could possibly access gravity, see gravity in action, as it were, in particle accelerators, at things as big as the LHC. And in that case, you would produce little black holes, which would then evaporate away very quickly, we think, through a process called Hawking radiation, and they'd be gone. So you can conceive of a way that you could, if given a big of a leap that there are extra dimensions in the universe, and given that they're configured in the right way, that you can imagine that you could do it. The interesting point, though, is that so LHC it's a tremendous technological achievement, but it collides particles together at energies that are just insignificant compared to the energies that are available in the universe to nature. So cosmic rays, for example, hit the Earth with energies far in excess of those that we generate at LHC. So whatever physics you can conceivably access at these particle accelerators is already being accessed now in the upper atmosphere of the planet, because the cosmic ray collisions are immensely higher energy. So if you can make little black holes because there are extra dimensions in the universe, then they are raining down on us now. They're here. They get made because the energies of the LHC, as I said, astrophysical processes all over the universe, way in excess, way exceed those energies. We're not very good at doing high energy collisions compared to nature, compared to supernova explosions, and compared to and cosmic rays. There's a cosmic ray actually that was detected. I think the highest energy one had the energy of a professional tennis player's serve. So a 100-mile-an-hour tennis ball, right? And it's a single particle. So you imagine getting hit by a 100-mile-an-hour professional tennis player's serve on the back of the head. There are cosmic rays with that energy. But they're like, one particle.
One particle would be equal to getting
served. The energy of a 100 miles an hour tennis ball. So these are incredible energies, way beyond anything.
How many particles would be in a tennis ball?
Oh, it's a good question, that. So let's do some. Let's have a think. So Avogadro's number is, what is it? 6 times 10 to the 23, isn't it? That's right. So that's the number of particles in the number of atoms. Let's say in 12 grams of carbon. So it's of the order of, so 10 to the 23 is 10 to the 24 is a million, right? So a million particles would be what you'd have of atoms of carbon. You'd have you're putting me on the spot here, aren't you? That's what you'd have in about, 60 grams of carbon or something like that. So if I was to guess, I'd say something like that. Million.
And that's
chemistry. That's chemistry. See, I don't do chemistry.
But that's out there just floating around in the galaxy. Like when a hypernova, you're still trying to do the math?
Yeah, well, I just made sure, because we're live on the web. I don't want to get it right. I get all.
Yeah, people do that all the time. This show's all about wrong answers.
Yeah, you got that wrong.
You're just talking.
Just
it's not your field of study. I understand.
Well, it should be, really.
Really?
It's like chemistry. Yeah, I do a bit of chemistry. It's just particle physics, but bigger blobs.
I watched a documentary once on hypernovas, that when they were first discovering the gamma bursts in the galaxy, they thought it was aliens having wars with each other. That was one of the ideas that were being bandied about.
It's really great. I mean, people do legitimately look for signatures from alien civilizations like that.
Sort of, yeah, but it's kind of.
There's mad people who do it, but there actually there are papers written about. Because you might say, what would the signature of an interstellar starship look like? Presumably be a matter-antimatter drive or something like that. So you get these very clear signatures of matter-antimatter annihilation that we know about, because we do that. The particular photons, gamma rays with particular energies. So you can actually say, well, shall we have a look? What would it look like if we saw an interstellar civilization, an interspacefaring civilization? Could we detect the signatures? So there's a bit of work done on that, and we don't see any evidence for anything.
Well, when you see someone like the people that run SETI, search for extraterrestrial intelligence, and they're always like asking for funding, and they're like, we need more funding, we have to figure this out, and one day what if we shut down and then the signal comes? Like, that seems to me to be like one of the biggest like Hail Mary wishes, like hoping that you're going to find a radio signal from a galaxy far, far away that has intelligent life in it.
Now a galaxy. Well, it's interesting though that if you ask astronomers, so you say, what's the probability of other civilizations being out there? Then they will point, for example, to the new data from the Kepler Space Telescope, which tells us that there are probably around 20 billion Earth-like planets in the Milky Way galaxy, in the sense that they're small rocky planets in what's called the habitable zone around stars.
The Goldilocks.
Around main sequence stars like the Earth, like the Sun. So 20 billion, so maybe 1 in 10 stars in the sky has an Earth-like planet around it, potentially. So that's a lot. So you think 20 billion? Well, surely life must have arisen on some of those. The answer is probably yes, I suspect. We may find life on Mars in the next 10 years, but it'll be microbes. So the question then becomes, well, how likely is it for simple life, if it arises, to make its way into a civilization? And that's where the biologists come and kind of calm the astronomers down and say, well, you might think there are lots of places for life, we would agree. But on Earth, it took 3.8 billion years to go from the origin of life to a civilization, which is about a third of the age of the universe, give or take. So you had to have an unbroken, stable line of life that evolves in the right way, as it were. First of all, it gets complex. I mean, there's a thing called the Cambrian explosion in the history of life on Earth, which was about 550 million years ago or so, which sounds like a long time. But for 3 billion years before that, there was nothing that we would call complex. Single-celled organisms doing some clever stuff like photosynthesis, but not much. And then suddenly you get a big jump in the oxygen content of the atmosphere on Earth, which was to do with photosynthesis and some geology in play with it. That's how the oxygen gets into the atmosphere. And then you get a big jump and you get complex life emerging. And then pretty quickly, 500 million years or so, you go from complex things to a civilization. But even then, you think about Homo sapiens we mentioned earlier, they only arose 200,000 years ago. So for the vast majority of the history of life on Earth, there's been nothing that could do anything clever in the sense of thinking and building spacecraft and radio telescopes. So there's a legitimate debate about whether the undoubted increase in... We know now that there are homes for life out there in the Milky Way. They're very common, and we know that. But what we don't know is the probability that life will emerge in the first place, and secondly, the probability that will turn into a civilization. And I think that's very low. So I think the probability, if I guessed, I would say the probability that life will emerge, given the right conditions, is very high. And what one piece of evidence you could put forward to that is that it did appear to emerge on Earth as soon as it could, after the formation of the Earth and the oceans. So you get life, but then it took a long time on Earth. So you might say, well, the probability of it doing anything intelligent and interesting are quite low, maybe less than 1 in 20 billion. In which case we end up being the only civilization in the Milky Way at the moment. It's possible. You can make that argument. And my experience is academic biologists tend to be on the cautious side, and astronomers tend to be on the optimistic side.
It's all relative, though, isn't it? Because even if we are only one out of this entire Milky Way galaxy, you still believe that it's possible for an infinite number of monkeys to create the works of Shakespeare. So when you look at the
that's
entire...
clearly a fact, isn't it?
You're right.
Yeah, because we did that with infinity, didn't we?
But if you look at the entire universe, then the idea of there being not just a life form like human beings, but the exact same life form is not just once, but an infinite number of times.
In the universe, absolutely.
In the universe.
Well, I'm sure. I mean, there are 350 billion galaxies in the observable universe. So it would be... Surely there are civilizations out there.
And more advanced as well, then.
Yeah, I'm sure that's the case.
Sure.
And it has to be the case in an infinite universe, as you say. But if we confine ourselves to the Milky Way, which is really the only place we
It's our
ever
hood.
have any hope of exploring or contacting anyone. We'll never contact anyone, even in the Andromeda Galaxy. It's 2.2 million light years away.
But-
we won't. But the Milky Way, if there's someone there, we could at least aspire to contact them. So it's worth that effort to listen. We don't spend much money on it. We spend too little on it, I think. It would be a tremendous discovery if we made it.
If
so
we
it's
found
worth,
something like us.
It's worth listening because, and when SETI started back with Frank Drake and Carl Sagan and others back in the 60s, then they had no planets had been discovered beyond the solar system. None. So the only planets we knew were our planets. Now, as I said, we've discovered thousands of planets, confirmed discoveries, and the statistics tell you there are billions of them out there. So virtually every star probably has a planetary system. So the statistics have gone in the favour of SETI from the astronomical perspective. But as I say, you've also got to have the time to make things like us, and that's a tortuous process. There's no inevitability to evolution. I think it's not to be seen as some march to complexity. Evolution. It does what it does. It's single-celled organisms were very, very good at just surviving and getting on with it for most of the history of life on Earth. So it may be that complex multicellular life is kind of just an aberration, really. It's just a bit of a lucky accident.
So it's all really just perspective when you think about it, because even though there is an enormous galaxy, relatively speaking, it's one tiny
It's not that big.
little thing in comparison to the rest of the universe.
Yeah.
So even if we could find something out there, the likelihood of it being as advanced as us are very small.
Well, no,
but it's just a matter of how far we can reach or how far we can see.
I wouldn't go that. Nobody knows it. What people do know, I think, is that the Milky Way is probably the boundary of our aspirations.
For this generation or
no, forever,
beyond.
I think. And
Forever?
I think so.
What if we live 100,000 years and people keep evolving?
The galaxy is 100,000 light years across. There are 200 billion star systems in it. It's big.
It's too big.
But that's not. So you could just about perhaps conceive in the far future of beginning to spread out into the Milky Way. You could conceive of that, given hundreds of thousands of years, right? But then you go, well, where's the next galaxy? Andromeda.
Right.
It's over 2 million light years away. So the idea that you would get across a distance of 2 million light years with any conceivable technology is, to me, probably. I mean, it takes a light beam to 2 million years. So if you want to talk to someone in Andromeda, it will take 2 million years to get a message out there and 2 million years to get it back. So there's a 4 million round trip. That's the nearest galaxy. So it's big, right? Space. That's the thing. But so you can imagine possibly the Milky Way. It's some chance if there are other civilizations there talking to them. But I think beyond that, I just cannot conceive of how it would be done.
Is this relative, though, in perspective to the single-celled organisms that existed billions of years ago in comparison to us? Do we really think that we're the end-all, be-all, and this is the last stop on the road to evolution?
No.
Isn't it possible that we get so advanced, if we live to be another billion years, that we can, all these ideas that we have in our head about the laws of space and time and what particle physicists are trying to figure out and what string theorists are prescribing as far as 15 different dimensions? Is that what you said? That one
they
day
change their mind all the time. That's pretty unfair to them. But
well, I want to get into that because I don't understand string theory.
no, I don't know.
But I don't understand what you're saying either.
No, you're right.
But my idea is that if we continue to go on the same path, I mean, isn't it possible that we will achieve some unfathomable level of technological proficiency or of control over matter or of an understanding of the universe at such a deep level that we can violate all these things that we now consider laws, like the laws of...
Yeah, so the laws would have to be approximations to some deeper laws. But
Right.
So Einstein's theories of relativity are the best theories we have at the moment of space and time, of space-time.
Thank God for Einstein. One dude.
Well, he was incredible. and general relativity actually is 100 years old this year. So that is its birthday.
That's amazing.
And so the speed of light as a fundamental part of the structure of space and time. Actually, is central to that theory. It's actually the thing that protects cause and effect. So it protects, if you like, the past from the present and the future. So it's built in a very fundamental way to that theory. So you are right in principle that and it's a speed limit in that theory, by the way. And by the way, there's strange things happen as you approach the speed of light. For example, the theory says that time slows down.
Right.
The thing that's travelling relative to us. So if someone, the number I know is the number for the protons in the LHC. So the protons go at 99.999999% the speed of light. So imagine one of those flying past us now, and you imagine it had a watch, a proton with a watch. You'd see its watch pass 7,000 times more slowly than our watch. So and it would live 7,000 times more slowly than us. So conversely, if it was watching us, it would see the same effect. So you can move through time at different rates, essentially, in Einstein's theory. The faster you go relative to somebody else, the slower your watch ticks.
I got an idea. We combine your world and the Kardashians, and we shoot them into space at the speed of light, and they don't age.
Well, that's exactly right. So exactly what you said. The cool thing about that's what I was getting to. So the thing about relativity is if you go at the speed of light, you don't age. No time passes. The kind of point is that you can't go at the speed of light unless you're massless. But that's a kind of So, but if you're massless, you have to.
Well, have you ever seen her
photons have
ass?
to fly
Good
around.
luck making that thing massless.
Well, exactly. So she would be limited to travel below the speed of light, not
Just
only due
below.
to even if she only weighed, even if she only 1 gram in mass,
She's a lot more than that. But plus, that's not a very aerodynamic object either. So
but it's in
good luck
space, so it
launching
doesn't
that
matter 'cause
sucker.
it's-
Oh, that's
well,
right. It wouldn't matter in space because it's a
once
vacuum.
you're dead,
Right.
So you're all right. So aerodynamics. But still, so it's a fundamental thing. So if you're going at that fundamental speed, there's no time. There's no distance actually either. All the distances shrink to zero. So it's a what I'm trying to say is it's a fundamental part of the structure of space and time. As
So
far
it's
as we know.
impossible.
So you would need a different theory. So it's literally impossible in Einstein's theory to go at the speed of light unless you're massless, in which case you have to go at the speed of light.
Could you go just under the speed of light and then time would
Yes.
just slow down?
Yes.
So it wouldn't stop, but it would slow drastically.
Yeah. Yeah. So as I said, 99.999999% gives you a factor of 7,000.
Now, here's the question. If you somehow or another were able to go 99.999% of the speed of light, what would happen in your perspective as far as time? Would
pass
time
Normal rate.
at a normal rate?
Yeah.
So you would age at a normal rate in your perspective.
Yes.
But back home, like if you came back around, if you went out into space and you went 10 years at the speed of light and you came back, everything would change, but you'd be exactly the same.
Yes. What would change for you, though, something has to change. So it's the distances. So if you travel, so the other thing is let's talk about the protons in the LHC again. So
Okay.
their time's passing 7,000 times more slowly from the perspective of someone stood on the ground watching them go round. But from their perspective, time's going at the same rate, but something must change. So what is it? It's the distance. So the LHC is no longer 16 miles in circumference. It's about, now I know the number in metric, so it's 4 meters. So that's, what is that in feet?
3 feet,
12
the
feet,
meters,
12
like
feet,
3 point,
12 feet.
12 feet, yeah.
Something like that. So it's 12 feet. So it squashes. So distances shrink from the perspective of the protons. So time passes at the same rate, the normal rate for them on their watch, but the distances seem to shrink, or do shrink. Not seem to, they do.
Are you concerned at all about artificial life? Are you concerned at all about the creation, the inevitable creation of something that in some way replicates independent thought and acts on its own accord? I always wonder if human beings are, in some sort of a sense, a technological caterpillar that's becoming a butterfly, and we just don't realize it in all of our work. If you look at one of the things that human beings are absolutely fascinated with, whether or not it benefits us or not, we're fascinated with technological innovation, where we want faster computers, even if we don't even have applications for them. We want cars that go 0 to 60 in 2 seconds. We want everything to go quicker and better, and we don't get satisfied. Like, nobody ever looks at computers and goes, we're good. We're good. We don't need a bigger laptop. We don't need a stronger hard drive. Everything seems fine. Let's stop innovating on computers and move towards cancer research or whatever. No, we're never going to stop. And I always wonder if whatever drives us, what if it's similar in some way to a caterpillar building a cocoon, about to give birth to this new thing, totally unaware, and that artificial life, that our work with, whether it's code or whether it's electronics or whether it's 3D printing, a combination of all those technologies coming together to create some new form of life. And we don't think of life being possible in an electronic sense because we think of life as being cells and blood and all the things that we are. But is it possible that we might just be building the next thing that, we look at, well, we've only been alive for 200,000 years. Yeah, but we might be shitting out the new version of life.
Yeah.
With our constant fascination with materialism. I mean, what is materialism ultimately, if not a push for innovation and technology? A big part of what materialism is keeping up with the Joneses, getting the latest and greatest. Look at this. This guy's got a new TV. It sees your fucking brain, it looks through your soul. You could play back your history. It gets a fingerprint. You read it. It takes your DNA and it shows you what your ancestors were doing 2 billion years ago. I mean,
well, there's another aspect to R&D besides consumerism, isn't there? There's increased life expectancy, decreased child mortality.
There's great things too.
But I agree with you. I agree with you. I don't see any reason why AI is in principle not possible. Right, because I think that although, the research, we don't understand the brain, but I think it must be an object that operates in accord with the laws of physics. I strongly suspect that our conscious experience is emergent, so it emerges. So there's an algorithm there, a very complex algorithm, but I don't see why it can't be simulated in a sufficiently powerful computer in principle. So I don't see why you can't have a conscious computer. I don't personally see why you can't. Therefore, if that's true, then you can, given them. And as you say, the rate of increasing computing power is rapid. We're not there yet. There is a project in Europe, a very big project to build a brain simulator. It's a long way off, and you're talking about billions of dollars. But at the moment, as you say, that 40 years ago, $1 billion wouldn't have bought you an iPhone computer.
Right.
So yeah, I agree with you. And actually, and as you said, 3D printers essentially seem to be the first step on the road to a self-replicating machine. So you've got the computing power that can be intelligent, and you've got a means of it being a replicator, then I don't see why you can't build AIs that replicate. And actually, going back to the cosmology for a minute, one of the arguments against the existence of civilizations, more advanced civilizations than us in the Milky Way, is that they would have done that. And this is an argument from a mathematician called von Neumann and also a physicist called Fermi. It's called the Fermi paradox. That let's assume that let's fast forward, as you said, let's fast forward our civilization 10,000 years, let's say, blink of an eye. Let's see. We've been around for less than that as a civilization. Let's double it, 10,000. What are we going to look like? Will we have built self-replicating AIs? Yeah, unless there's some reason in principle why you can't. So what do? You send those out. They're replicators. They can go to asteroids, mine, print, 3D print a version of themselves, go off again. They exponentiate. They can crawl over the galaxy, exploring for free. You send them out. We see no evidence of those things. They're called von Neumann machines. So it's one of the great... You can either say that there's something in principle that stops you doing it. So actually there is something special about intelligence, and you just can't... There's some reason why you can't build a computer that's artificially intelligent. I don't see why that would be the case. Or you could argue you can't build a self-replicator, but you can, because we are replicators, and we operate in accord with the laws of physics. So there's a replicator. Or... the reason we don't see them is because there aren't any civilizations that ever got to that level in the Milky Way.
So we're the tip of the spear.
No one. Well, we couldn't be the first. It's very difficult to see how we could be the first.
Someone has to be the first. Why can't it be us?
But because the Milky Way's been around for the age of the universe.
So you say. So, don't you know the Earth is 6,000 years old? Do you not go online?
Putting that aside. So the timescales, we're talking billions of years.
Right.
Billions of planets, billions of years.
But it has
So
to happen
either
one time,
once,
somewhere.
and then and if you get one wave of these AIs away into
Right.
space, then you can show, using computer models with realistic assumptions about rocket power and things like that you can cover the galaxy on timescales of much less than a billion years, actually million years, less than that. So you can show that you can cover the galaxy in your von Neumann probes, your replicators, in hundreds of thousands of years. Let's say 1 million, 2 million, 3 million, 10 million. Doesn't matter, because we've got billions of years, and yet we see no evidence of them. So what are we to make of that? Either there's something wrong with our argument that we're putting forward, that actually you can't build self-replicating intelligent robots. I don't see why not, but maybe there's something wrong with that. Or really, civilizations are so rare that, as you say, we are the first to get to that level. But that's interesting, isn't it? That would be an interesting... I always think in a almost Sagan-esque sense of this. So imagine we're the only civilization in the galaxy. What a tremendous responsibility there is on us. Imagine what that knowledge should do to our political processes, the way that we think about ourselves, the way that we get on together. Imagine how ridiculous it is to divide our little world up into countries and have a little war every now and again and point nuclear missiles at each other, if in fact there's nowhere else in the Milky Way galaxy where anybody thinks, where anybody can look at the stars and think about and have these conversations. What a ridiculous way to behave. So I think cosmology gives a perspective which is doesn't necessarily need to be humbling. It is humbling, and that's perhaps a good thing, but you don't need to be depressed about it. It could be quite elating. You say, well, what we are, according to the evidence and the data at the moment, is almost indescribably special. Our tininess, our potential uniqueness, our insignificance in a cosmic scale actually makes us special, because we're the only place. And so these ideas are worth pursuing, I think, because they make you think about these issues.
Well, doesn't it also point to our ego that we think that our biological process is any more important than the exploding suns that are required to create carbon life in the first place, or any of the processes of the universe?
The answer to that, I think, is that you're right, that in a completely logical sense, we're no more important or less important than the stars themselves. You're right, we're just natural objects. But I would counter by saying that people look for meaning in the universe. People like to look for meaning. It's one thing that we've done since we began to look at the stars. The universe means something to me, doesn't it? It does. Meaning exists because it means something to us. So we know that. It would be ridiculous to say the universe is meaningless. It means something in my head. We have families, we have loved ones, etc. So the fact that meaning might be emergent, it might appear from the laws of nature, and it is almost certainly transient unless we build these self-replicating machines. We're not going to last forever as a civilization, probably. So that to me, that doesn't in any way water down the significance of it. So I think, again, cosmology can be a powerful aid to philosophical thought in this sense, because we have to accept that there's meaning in the universe because it means something to us. I don't see why it has to be eternal. I don't see why that meaning doesn't imply purpose. I don't think there's any purpose to the universe. I don't think there's any point to our existence. But the fact that we exist at all is worth celebrating. You don't need to add anything else. In fact, you almost, for me, you devalue it. It's like, why would you? This is remarkable. We emerged single-celled organisms. Probably before that, we emerged as some chemical reactions in hydrothermal vents, probably down in the deep primordial oceans of ancient Earth. And over 3.8 billion years, we've come to the point where we can sit and think about the stars and have conversations like this. Is that not enough? I think it's a remark. Can we just leave it there? Why does there have to be a point? There isn't a point. I don't think there's a point to that, but it's worth celebrating.
Well, it certainly is to us. To us, it's amazing. But in a lot of ways, isn't looking throughout the incredible cosmos for signs of life like looking in a sea of parked Mercedes-Benz for dust? Like, one of these cars must be fucking dusty. They just cleaned them. I'm going to find it. And you're ignoring the incredible mechanisms that are in front of you. This amazing technology, anti-lock brakes, fucking 12-inch computer screens. They don't even have gauges anymore. The cars drive for you. They steer for you. They brake for you. And we're like, one of these motherfuckers has dust on it, just like us. I mean, these planets, we talked about our planet being 4.6 billion years. The universe is 13.8. We're looking for things that live 100 years. We're like, there's got to be one out there that sings songs.
Yeah.
Somewhere there's a better rapper than Jay-Z, and he's out there in the universe.
Well,
we got to find him.
But
We got to find him. This is a search, and we're ignoring asteroids and gamma rays and
the search for better rap. We should rewrite NASA's reason.
Yeah, but again, though, it doesn't take anything away from the fascination of just, one of the beautiful things about being a human being is that we think about these things, and that we can communicate, and that you and getting on this podcast you're planting all these seeds in people's minds that are making them consider these thoughts, and now it spreads. And that's one of the most fascinating things about the idea of intelligence, is that intelligence begets intelligence. Intelligence sort of stimulates other intelligence. It's not simply, I think one of the reasons why you love educating is like, how important this is for you, and you've seen the spark in people's eyes when you explain these things to them, and you realize that person might spread that spark somewhere else. And this is really what this process is about in the first place. But it has meaning to us, but in the grand scheme of things, we're just exporting Kardashians through the universe.
Well, we could make a start by exporting the Kardashians to the universe.
The beginning, and then the resistance of exporting the Kardashians makes people, the new version of Cosmos with Neil deGrasse Tyson, that gets out there too.
That makes me optimistic, actually, because I wouldn't have thought.
I think it's all together.
Would be done. Again, I have to, because Carl Sagan, great hero of mine. The fact that it would be done and put on Fox on a network, in 13 episodes of it.
Yeah,
it's true. It is. There are people out there who want to do it. Yeah, it's very important.
Most certainly, and more so now than I think ever before, and more so in the future. I think even though there is evidence that people are dumb as shit, there's still more evidence that people are super curious. I think it's just it's a numbers thing, and if you spoon feed people the same thing over and over again, like there's the argument for a limited network, especially American style, you could just sort of do it the BBC way, but the BBC way is beautiful in that it sort of sandwiches these brilliant shows in between other shows, but not enough. There's not enough room. There's too many things out there now. You only have 24 hours in a day. There's no fucking way you're going to have enough programming. Unless you have an infinite number of BBCs, you can't. There's just too much shit going on. The world is too vast. And that's not discounting anything that the BBC's ever done, because one of my favorite networks. I have this Congo series that I've probably watched a dozen times about the BBC, which is one of the most fascinating documentaries, not just on a particular area of the world, but on life itself adapting, which is like the primary sort of theme to that documentary, where they're talking about these parts of the world that were changed really rapidly over a period of a couple thousand years, where it used to be plains, and then it became these dense rainforests, and there's all these animals that are sort of trapped in this world, like rhinos and plains animals, and there was a piece on these a type of antelope called a duiker that swims underwater 100 yards. They can fucking swim. They eat fish. It's craziness.
Swimming antelopes.
It's like related to an antelope. But the idea is that you're talking about a very short period of time, a couple thousand years, that's had this rapid amount of change. These animals have had to adapt to this very strange new environment.
This is, I think, the inability of some people to understand evolution and react, and therefore react against it. I don't think it's all actually just religiously motivated. Most of it is, but some of it isn't. I think there's also a lack of understanding of the timescales involved and how fast animals can adapt and change, and what a powerful sieve, if you like, evolution is. You can see it. Richard Dawkins often, right, when he's writing beautifully about these things, writes about look at domestic dogs and look how quickly the wolf got turned into these somebody from poodles to German shepherds to whatever it is, all those things. Now that's selection by humans, right? So we're selecting for particular traits, but the environment and the interaction with other species is as powerful as that. It's as efficient as that. The environment is a very powerful selector of traits, and so you can see that evolution happens quickly, speciation happens quickly, and not quite with the dogs, they're still the same species, but you can see how given a bit of time, you're going to get the poodles and keep going on that line and get the wolves and keep going on that line, and eventually you're going to get things that look so different that if you separate them and don't let them interbreed, that you're going to end up with something that can't breed with that anymore. And that's kind of the definition of a new species, one of the definitions of a new species. So you can see how it can happen. It's obvious. And I think one of the problems is the timescales are not understood. When you talk about thousands of years, that's quite a long time. 10,000 years is a long time. 200,000 years, you go back that long, and we didn't exist as a species. We weren't there. So hundreds of thousand years is a hell of a long time.
Yeah, too long to, I think, in our mind to process. Like, we can kind of process a lifetime. We can process birth to 100 years. Wow, he lived to be 100. Wow, what a lot of things that guy must have seen.
Yeah.
But to process 100 of those,
yeah,
100 How about 1,000? How about 100,000?
Yeah.
It's there's too much going on. There's too much change.
Yeah, it's a long time.
Do you subscribe to the idea, and I've heard this debated about, that human intelligence may be in some form exponential, and that all the knowledge that people have acquired, I mean, obviously not like in a physical sense, like you're not born with an understanding of math and language and all these things are learned, but that intelligence may somehow or another be not just passed on from generation to generation, but enhanced by life's experiences, and that the genes that are transmitted from you to your children may be in fact more powerful than the genes you were given, and that as you've lived your life and acquired information and knowledge and understanding and whatever intelligence means, whatever sort of intangible idea intelligence truly is, but that this mind power, this accumulation over the 200,000 years that human beings have existed and people breeding and getting to this point, that this might exponentially be growing and expanding. Is that in any way possible?
I'm not an expert on genetics. I don't think so. I don't think there's any evidence, as far as I know, that our IQ, average IQ, has changed much over the last few hundred years, certainly. So as far as I know, that's not the way that it works. You need, I think, some kind of selector that would say you'd have to take the most intelligent of us by some measure, let's say, and have them be more successful at producing offspring than the people who are less intelligent. You'd have to do something.
But isn't that,
you need some mechanism.
That been proven? Like, haven't they done like those? They do those sperm banks with really super intelligent people, and the kids that come out of it are smart as shit.
Oh well, that I can imagine that might be true.
Right.
I don't think we know. I think the correct answer scientifically is we don't know the link. We don't know enough about the genetics and the genome, the human genome, to say which bits are producing brain power, if there is such a thing. What is it? Which genes? Is there an intelligent gene or a set of genes? And I think that's not known, I think, is the right thing to say. But as I emphasise, it's not my field
of
so
study. But it must be something you ponder when you think about evolution. You think about genetic knowledge, and that certain things.
Well, that I would perhaps argue with the idea that I know there's some interest in this, but I think the standard answer is that the knowledge, let's say, so I become educated, that I think the standard answer is that would not have any impact on the genes that I pass to my offspring. I don't think there's any known mechanism to have knowledge imprinted somehow back into your genetic code such that it can be sent on to your thing. But you may have seen otherwise. I'm not aware of any research.
Well, it's hard to look into a kid's head and find out exactly where all the information is coming from, right?
Yeah, but I don't think there's a known. Well, there isn't a known a known... What's that? There's something...
We had a
there.
TriCaster just freeze up on us. People at home right now are freaking the fuck out. We were just about to get to the bottom of this. Instincts. Like, humans have certain instincts, right? Like, there's people have fears, like genetically sort of predisposed fears to, like, scary dogs, animals. I mean, we know. You don't have to have a dog bite you to know that a dog is fucking terrifying. Like, what is that? Like, when a dog is like growling, like, kids are afraid of teeth. They're afraid of big teeth and monsters.
True.
Like, even children that grow up in cities, they're afraid of monsters. And the idea behind that I've heard, I think it was Rupert Sheldrake that was talking about this. He was saying that it may very well be that these memories of being preyed upon by, like, cats, like that, these genetic memories that are from our ancient ancestors when we didn't have homes and we were living in trees and things were running after us trying to eat us. That these ideas are passed down from animal to animal and eventually human to human.
I don't think... As I say, as far as I know, there's no solid evidence that suggests that things you experience as an adult or as a child, the experiences themselves can be passed on, other than verbally to them when they're listening to your stories. I'm not aware of any mechanism that's known that would allow that to happen.
Haven't they proven that genetics, like epigenetics, and some memes, like even useless ones like racism, can be transmitted from parent to child?
Not that I'm aware of, but I don't know.
Yeah, this is obviously not my field of study either. I'm just fascinated by the idea that we don't totally understand all of the ingredients of the mind. And
that's certainly true. That's certainly true. But I'm not aware of it. I don't know. I doubt it because I can't see a mechanism.
Right.
But I don't know.
Are we back up, Jamie?
1 minute.
What's going on? The TriCaster froze?
Yeah, completely froze.
Oh, what a piece of shit that we paid $15,000 for. How dare you, TriCaster people. Meanwhile, we should probably be excited that someone figured that fucking thing out. You think it might have to do with the box and it gets heated up?
I have no idea.
No? Just shit out on us.
PC thing.
Yeah, most likely, right? How dare they? One of the things that was proposed that I read recently was that black holes aren't real. Is that nonsense? Is that like one person's controversial idea?
Yeah.
Yeah, basically.
So it's not necessarily nonsense just because it's one person's idea, but it's likely to be nonsense. I haven't seen that particular theory, so I don't know. I mean, we have a lot of good evidence for the existence of black holes, not least they're predicted. They're a prediction of Einstein's theory of general relativity. They're on solid theoretical ground, and we've seen the signatures of them. So, for example, the object at the centre of the Milky Way galaxy, we know what the mass is of that object because we've measured the orbits of stars very close to it. We know what the maximum size of the object can be because it can't be bigger than the orbits of the stars that go around it. And so we measure its mass. I think it's about 4 million times the mass of the Sun. And the only way that our current laws of physics allow such an object to exist and be so small is for it to be a black hole. So there's good evidence that black holes are around. But you can always say, well, we haven't been to one. They're very hard to photograph because they're black. But you can photograph the stuff that falls into them. You can see the signature of stuff falling into them, which we do.
And they've what was it like? It was the somewhere in the 2000s they figured out that at the center of every galaxy is a supermassive black hole that is like 1/2% of the mass of the galaxy, or something along those lines.
We think so. As I said, I think so. Off the top of my head, I think it's about 4 million times the mass of the Sun.
And so the larger galaxies would have a larger black hole.
I'm not sure if it's that. It's not well understood, actually, because it's not well understood how galaxies form in the first place. And what role these supermassive black holes have in the formation of the galaxies. So that's a real active area of research, actually. So it's a good question.
The thing that I was reading was they were debating the possibility that inside each one of these supermassive black holes, so like there being hundreds of billions of galaxies, each one of them with a black hole in the center of it, a supermassive black hole, in through that black hole is a whole nother universe with hundreds of billions of galaxies, each with black holes, go through that whole 100 billion more galaxies, each with black holes, go through that 100 billion more. I mean, that each galaxy itself literally is a portal to a completely different universe.
The point, we don't have a...
Right.
The problem with black holes is that they're a prediction of Einstein's theory, One of the earliest predictions is a thing called the Schwarzschild metric, which describes black holes. It was done, I think, in 1915 or 16. It's right as soon as relativity was published. It was shown that these things could exist. But we don't. The theory itself breaks down. Then
The theory of black holes?
The general relativity, which is the theory that explains Einstein's theory, which sort of predicts their existence, but it doesn't. The characteristics of black holes, the physics inside black holes, is not understood. We don't know. Our theories don't work. We need what's called a quantum theory of gravity to make progress there. So that's the unification of quantum theory and relativity. And general relativity, which is what string theory is an attempt to do, but we don't know whether that's the right theory. So this is the edge of knowledge. So we don't know. So we don't know what we don't know how to describe black holes properly. We don't have a theory that's capable of describing. We can describe the edge. So this thing about an event horizon and all that stuff, that works. That's not a problem in Einstein's theory. So the idea that if you have a sufficiently dense object, then there's a region around it out of which light can't escape because space and time are too curved for light to get out. That's fine. The theory describes that properly. But when you start asking questions about what happens at the centre of a black hole, the singularity, the very idea it's called a singularity tells you there are infinities in the theory. The theory is doing things. It's infinitely dense. It's infinitely small. Well, no, it won't be. We don't have infinities in general in nature, other than perhaps the size of the universe, as you say. But so there's something going on there, but we don't have the physical theory. We don't have the tools to describe it. It's an active area of research. So I don't know is a good answer in science, right? And so speculation's fun, but ultimately, we're talking about a regime of nature, which our current theories are not capable of describing with any authority, and that's the inside of a black hole.
We were talking about this before the podcast, the difference between the way you present your shows in the BBC and the way you're sort of forced to present your shows on like the Science Channel, and this was one of the very issues.
A little bit. I mean, that's a bit strong.
A bit strong, but dealing with unknowns, dealing with when you're describing things like black holes or like the event horizon of a black hole, that there are points in time where you have to say we don't know yet. Yeah,
no, we were talking earlier, and I'd said because at the moment we're so I have a series in the UK called Human Universe, which has been on in the UK, 5 episodes, 1 hour long. So we also make them with Science Channel, and the Science Channel's 1 hour is 43 minutes because they have adverts, right, commercials. So fine, that's the way. So we've got to take 17 minutes out, but also we have some interaction about, well, how do we nuance things for the, because you'll do things for a British market that will be different in the American market. And one of my favourites recently was that. So one of the programs is about this multiverse that we just talked about earlier, the fact there may be an infinite number of universes. The universe may have been around forever. There may have been no beginning to the universe. All speculative, right? There may have been. So what does that mean? It means that our existence is inevitable. We have to exist in an infinite universe. And we are because we have to be. So there's no purpose to our existence. There's no universal meaning to our existence. We are because we have to be. And in the British version, I say, so to the camera, how does that make you feel? And the wonderful thing is, nobody knows. This is new physics. It's right at the edge. It's speculative. But we're beginning to address it with the data and the theories. So we need theologians and philosophers and artists and novelists. We need to discuss these things. What does it mean for us if our existence is inevitable and we're not special, but yet we may still be valuable? What does it mean? I don't know. So the last thing I say in the British version is, so what do you think? I say to the audience. And I think it's beautiful, and it's filmed over Tokyo skyline. I think it's beautiful. But I did get a note from the Science Channel saying, well, the thing is that this is not the style on the. So we tend to try and leave the viewer with some concrete things. So can you tell them what it means for the? So I'm going, what the meaning of life? The great existential question of what does it mean to exist? You want me to answer that? Yes, that'd be better for our audience. It's like, well, I really am a bit. I don't know. So I said, what can you tell me what to say? Perhaps I'd love it if Science Channel, if you know the meaning of life, then tell me, and I'll gladly say it on the program. I don't know.
Right.
So it's kind of interesting that there's that difference in style But I loved it that they said, we really do want you to broadcast the meaning of life on Discovery at 9 o'clock. Because I can see it would be a great sell, on Discovery tonight after Sharks, whatever they put on. After Shark Week, then we're going to do the meaning of life with Professor Brian Cox. Brian Cox will tell you what it means to exist, for your existence to be inevitable in a possibly infinite cosmos. Find out at 9. It would be good.
It would be completely subjective. What life means to you doesn't, Jamie has a different need.
This is what we do. I do in the series. This is what it's about. It's a love letter to the human race, human universe. You see that certainly if you buy the 1 hour versions, I don't know how it's going to pan out in 43. But if you get the 1 hour, which you can buy from good retailers on the internet,
can you get it on iTunes?
I found out you need a. It's not on iTunes at the moment, but you need a 1080i Blu-ray player. I will say.
You do?
And I found out
to
my
see
friends
it
that not all US DVD players play 1080i content. They play 1080p content.
What's the difference?
Technical stuff. One of them is called interlaced, and one of them is called progressive scan. There's virtually no difference, except that in Europe we tend to. So some of your Blu-ray players in America will play it, and some of them won't. It turns out. I just found out.
Oh,
yesterday,
so they won't play it at all.
They won't play it.
It's the wrong
on the Blu-ray. You can buy it, but and I encourage you to because it's wonderful. but there's something. But it'll be on Science Channel anyway in a few months. But it'll have cut down a bit. But the central message is this: that what we talked about earlier, that it leads you, I think, to value the human race. So there's a lot we filmed in Ethiopia, which I love. I always love filming in Ethiopia because we're in the Rift Valley filming this story about the emergence of humans from the Rift Valley. And we filmed in somewhere called the Danakil Depression, which is one of the, other than Death Valley, it vies with Death Valley often for the hottest place on Earth, but it's far more barren than Death Valley. It's up in northern Ethiopia on the Eritrean border. There are volcanoes and it's bleak, but there's a tribe of people called the Afar that live there. And they're fascinating. I stayed with them a few years ago. And they don't have a concept, for example, of possessions because they don't have anything. They just live on these volcanoes in this wasteland. So if you put something down, like something, then they will legitimately pick it up and they'll say, well, it's kind of, I'm going to use it for a while. So when you're a film crew, you kind of, there's no cultural idea. They're not stealing, they're not taking stuff. They don't have that idea because they don't have anything. So if you leave a camera, they might get your camera. And we had some guards with us from the Afar tribe because it's a bit dangerous there. And he had an AK-47, this guy, and he sat there with his AK-47. And then we woke up one day and we had a mountaineer with us, and he got one of his mountaineering ropes attached to his AK-47, and he sat there now with this guy's rope. So the guy said to me, shall I ask for it back? I was like, no. But number one, it's attached to an AK-47, right? Which gives him the advantage, presumably we get into an argument. And number two, it's fascinating. They have no idea of possessions. But the reason I started saying that was because we were filming, we talked about meaning in life. And we said to this man, he was called Aidan Ali, a guy at the Afar tribe, small man, probably 4 foot tall, right? Old. And we said, we were talking to him about this through a translator, and he said to us on camera, he said, your eyes have your age, but your ears have your father's age. Your ears hear the past, and your eyes see the present. And this is the way you should live. And I just thought, this amazing, beautiful thing that came out of this man. And so we put that in the series just and subtitled it and left it there. So it's full of little just people celebrating those people. It's something you'd never see. You don't think there are people who live on volcanoes in northern Ethiopia that say wonderful things about your ears having your father's age and your eye and the past being used through your ears to manipulate and inform the way you behave in the present. Beautiful, deep thoughts. So we tried to fill the series with those things as well. So it's a mixture of cosmology and this celebration of the wonder of human existence, the diversity of human thought. So there's beautiful stuff in there.
A love letter to the human race.
Yeah, and why not? Because we deserve it.
Well, we're so adaptable. The idea that people can live like that with no possessions at the same time where people live in a world that are one of our biggest issues is that people live to accumulate possessions. And the idea of materialism is it's like it very much like you were talking about the 17-year-old boy that only pays attention to video games, that becoming obsessed with anything, whether it's becoming obsessed with objects, becoming obsessed with ideas. Man, human beings, we are so flexible. We're so flexible in how we can exist as a culture or as a community, that our ideas are so rigid that people have to be this way. And you can't run around on the internet saying that there's no meaning to life when Jesus' name is being broadcast right now on Christian ministries all throughout the world. They understand what the meaning of life is all about, Brian Cox.
Yeah,
you are the one who is ignorant to the ways of the Lord.
And I do think that what I've found is that travel, because I was just filling in actually for Infinite Monkey Cage. For Infinite Monkey Cage, because we're doing the shows and they're live, you have to have a different kind of US visa, right? So and the visa you have to put where you've been in the last 5 years. How many countries have you visited within the last 5 years? And I counted it, it's 38 I'd been to filming these things. 38 countries.
Wow.
And I thought, wow, I didn't know that. That's a lot, And what's interesting, what I found, it really honestly, is that when you go to Ethiopia or India or Japan or out into the wilds in these places, people tend to be relatively, well, everyone I've met has first of all been interested in stuff. So through the translator with the FR tribe, we talk about the stars, and I talk about the stars, and they're interested. So they've never been to school. They have their own education. They're up there learning about how to live in a volcanic wasteland, but yet they're interested. And the things they're interested in are common, I find. And I genuinely haven't met anyone that I found uncomfortable. I was uncomfortable with. I haven't met any of the maniacs that we think of as populating the world. We think, well, it's okay here, in North America or in Europe or something, we're okay. But there's all these wild people out there, So I just haven't seen any evidence of that. And so that's part of human universe. It's just trying to put these impressions. Yeah, they believe different stuff. So you might think, like you said, there's the people who say, well, Jesus is the way, but then you'll go to India and you'll find that there are people who are Hindus who strange beliefs to us, the Ganesh, the blue elephant god, and people, and they're part of their fabric of understanding the universe. And I find it wonderful, actually. It tells you something. That there are some things that are cultural and some things that are not. Religion's cultural. You go different places, you have different religions. That's not to say, although I don't have any interest. I don't have any interest in religion. I always say, people ask me quite a lot, do you believe in God? And I say, no, but I don't really even think about it until I get asked. I would have never stumbled across that concept myself. I get asked a lot now because I do science on television. I always say the same thing, which is I'm not really interested. I don't think about it at all.
Does that upset anybody?
Well, kind of, because I don't want to be dismissive. I'm not trying to be dismissive.
You're just talking about your own personal interests.
Does that upset?
No, I mean, what I'm saying is I'm just reaffirming what you're saying. You're just talking about your own personal interests.
Yeah.
Like why does your personal lack of an interest in something upset people? But it seems to, right?
Well, it can do, because I think it's a central part of the framework they use to explain the world and meaning and all these questions that we're discussing, which are difficult questions, and I think don't have answers. Right? I don't. It's a complicated question. What does it mean to be alive? As we've said, it obviously means something personally, but I don't. These are complicated questions. But I think what's interesting is you go around the world and you see that these questions are common, and people think about them in wherever they are, whatever their level of education. They have some framework for understanding that. But there are also the commonalities are large. The curiosity about the stars is something that you see everywhere. You see, the curiosity about the origins of the universe, and there are stories which are different all over the world. All, in my view, and in the human universe view, they're equally valid, right? They're all worth. I don't recoil from them. I think they're interesting. They're interesting responses to nature, I think.
So these people that live around this volcano, how do they survive? What are they eating?
They have goats that they manage to sort of feed on the limited, tiny amounts of limited vegetation that's there. There's very little water, so they're very careful with the water. But they've developed this way of living. They're a remarkable, tough, really tough bunch of people.
How many people live up there?
I don't know actually how big the FR is, but it's one of the. Ethiopia is very tribal, and it goes into Eritrea as well. So it's in this area at the top of the Rift Valley. It's called the Triple Afar Junction, which is a tectonics, plate tectonics. It's where all the volcanism at the top of the rift is. So it's the generator of the Rift Valley, if you like, which is beautiful actually as an idea, because this is the cradle of humanity. So you've got this. I find it a magical place actually, Ethiopia, for that reason. And I recommend it actually. Addis Ababa is a beautiful city. It's a high altitude city. So Ethiopia, you tend to think of, especially if you're kind of my generation, you think of Live Aid and the big famine in Ethiopia. You think of this dusty place, and it is in some areas. But actually, the capital, it's a very green country. It's high altitude, quite a pleasant city, because some African cities, when they're very hot, and they can be very unusual for people like us from places that are not dusty and hot. But Addis is not like that actually. And I find there's an idea when I go there. I like there's an idea that because you kind of almost know that we came from there somehow. You come armed with this knowledge that we were all related to someone who lived here in and around Addis Ababa in the Rift 200,000 years ago. We're all related to someone who lived there. And we wandered out from there. I find that a powerful thought, actually. And it dismisses, the great deal of talk of differences amongst us. But actually, if you go to Ethiopia, you realise very soon that it's not far back, because you said you trace your generations, parents, father, grandfather, back. You don't go far back before you get to an Ethiopian, which is quite wonderful, I think.
It's so perspective enhancing too, to see people in this day and age. I was watching a documentary on people that live in the Amazon that are barely contacted by the Western world. They sort of they may have American underwear or something that someone gives them, but other than that, these people have been living essentially very similar to the way they've been living thousands of years ago, and they're getting by. They're fine, and it makes you realize how this world that we live in right now, that we think everybody has to have an email address, everybody has to at least have some form of public transportation. No, they don't. You don't have to have anything. These people all walk around. They walk around in the jungle and they live. And they've been living and they know what to eat, they know what not to eat, and they know what to avoid, and they have babies, and their culture continues, and they don't even write things down. And they've been living like that for a long time. And they're people just like you and just like me. Yeah.
With the same, I find the same level of curiosity and interest. It's kind of
sometimes more so.
Well, yeah, exactly. Exactly. So it's very interesting that perspective.
The people that you contacted in Ethiopia, how many are in their group? The ones that you were in contact with?
There were maybe, I'd be guessing 100 or so in this kind of.
Do they have a written history?
Village. No.
Oral history.
Verbal. Yeah. So these are stories passed down from generations. So they're great storytellers.
Wow.
As a result, in these isolated tribes. I mean, obviously, Ethiopia is a fascinating country because it's one of the few countries in Africa that's an ancient country. I mean, they're there in biblical times. They've got these myths about. When you go to Addis, they say we've got the Ark of the Covenant.
Oh, that's right.
In the cathedral in Addis, and you say, "Can I see it?" And they go, "No." I can't look at it, but it's there. I like the mythology. The mythology is that the Queen of Sheba was up there and stole it, I think, and came back and brought it back, stole it off King Solomon. It'd be Solomon, wouldn't it? So you've got this. It's all intertwined. So the fact that their written history, the central Ethiopian written history, it's biblical in its span. It's about ancient Egypt. They were part of that thing, that Egypt and Ethiopia, and then into Jerusalem and those areas, Palestine, and then out to that 1,000-year-old, 2,000-year-old history is part of that country, very centrally part of it. Whereas usually in Africa, you get countries that have been divided up and they came after the Second World War and they're post-imperial things. But Ethiopia is in that sense, it's a more grounded place in history. So it's a fascinating place.
What is the area that's supposed to contain the Ark of the Covenant?
It's in their cathedral, allegedly. In Addis. As I say, I wasn't allowed to see it, so I'm verified that it exists. But
how many people are supposed to be looking at it?
Nobody. There are issues with this myth that
so
you're not allowed to look.
Is it like Al Capone's vault, where it took Geraldo Rivera to break down the wall before we realized there was nothing in it? I mean, is there a room that no one goes into?
I think broadly speaking, yes. Other than the priests and things running, I think.
Is there
the
someone
basic idea.
that's supposed to guard it, maybe?
Because someone must have built the cathedral, And obviously the Queen of Sheba stole it in the first place.
Oh, so it's not there anymore, or it is?
No, it's there. No, it's
there.
She stole it from Jerusalem.
Oh,
I
and
think.
brought it to
And I
Ethiopia.
think that's right, and took it down to Ethiopia.
Imagine
It's
if it
wonderful.
is something, some technological object from a forgotten time.
Yeah, you wander in and go, oh, yeah.
You know when
Well,
they
I saw
find
it on Raiders of the Lost Ark.
Yeah.
So it does exist.
It melts faces.
Yeah.
Do you remember there was some work that was done on ancient batteries where they believe that some of the artifacts they found, like Egyptian pyramids,
Yeah, I saw
perhaps, might have functioned in a very similar way to a modern battery.
I saw that. Yeah, I mean, it's possible, I suppose.
Right.
We talk about timescales. It's 3,500, 4,000, 5,000 years. You know, the earliest pyramids, I think.
Right.
Yeah, we don't know. We know quite a lot about the Egyptians. Again, I'm talking about human universe. I'm supposed to talk about monkey cage, Anna, but I'll talk about human universe as well. Because we found. My wife actually started learning Egyptian. She was just interested in hieroglyphics. She just got interested, so she did some classes. And the literature from ancient Egypt is fascinating. You're talking about 2000 BC. These things that have been written down, and the earliest I wanted in the book of Human Universe, which you can get in the US, I should say. I went to look. I wanted the earliest literature. What is it? And it's basically one of the earliest things I could find was basically Monty Python's parrot sketch, right? Because it's a complaint. And it's like, I wish to register a complaint, right?
Really?
It's a piece of papyrus, and it's a complaint about. I think it was a coffin. I think it was a coffin manufacturer who'd supplied this coffin that was the wrong size, and it was kind of a bit of a rip-off. And this person was saying, I'm complaining about this. I want to send it back. This is terrible. I want my money back. And they'd say, oh, you can have 2 coffins instead. And they go, I don't want a voucher. I want my money. And you see this. What's wonderful is it's a modern voice that echoes down the ages from ancient Egypt. The most of them are either admin things about my garden you nicked a bit of my garden, you moved the fence in the night, or something like that, or complaining about some piece of commerce, like I've been ripped off by this shopkeeper and it's terrible, and it's wonderful. But then there are also poems, fantastic poems. There's one that about it's a woman talking to her husband. And the other way around, it's a husband talking to a woman. And so you go through and he's saying, why did you leave me? Why didn't you love me? All this stuff. It's quite touching and moving. And then you realise towards the end that this woman had died. She's dead. But he's still talking to her, because the Egyptians thought that, she'd moved on, a conscious decision to go into the afterlife. And so there's this kind of bitterness being expressed in this really moving piece of poetry. And then you realise that it's 4,000 years old, it's wonderful actually. So we haven't changed, is the point. You find from this old literature.
Well, one of the oldest pieces of human language was the cuneiform, right, from Sumer.
Yeah.
I read this one thing there was a passage they were talking about that was about divorce.
Yeah,
it was about marriage and divorce. There was something along like. I forget what, but it was like sort of a very short poem about divorce, about marriage, and for your relief or for your pleasure, divorce. It was very bizarre. Like the concept of 2 people uniting by ritual existed 5,000-6,000 years ago, and they wrote about it
BC.
in these little scratches. The cuneiform, which looks like ancient nails, with a flat top and a line that points down, and in a certain pattern, they've been able to figure out that it means some language that you can kind of attempt to translate to our modern languages in a weird, clunky. If you ever read like Russia, like the Russian translations from Russian to English, it's so bizarre because their language is so alien to us. It's so different that the way they use pronouns and the subtext and all the different aspects that we sort of take for granted about language don't translate correctly.
Yeah. And you imagine that for hieroglyphics.
Thousands of years
it's just
ago.
really difficult.
Thousands.
But I like the fact that the voices are so familiar.
Mm-hmm.
from those. We haven't changed.
The Library of Alexandria, man, the burning of the Library of Alexandria, if that had never taken place and we could somehow or another go back and read all the shit that they knew about construction methods and how they built those things and what was the purpose behind them and what was the significance of the astrological alignment, like what were they doing? Why were they, and what they were doing was so insane in comparison to the greater sum of humanity. Like if you look at humans in 2500 BC and then you look at Egypt, you're like, Jesus Christ, what the fuck happened here? How did you guys figure this shit out that no one else anywhere near was anywhere close to this level of sophistication as far as modern construction?
I think there's something you can take from this, because if you look at ancient Egypt, of course, if you go to some of the temples down there on the Nile and Luxor in particular, it's just astonishing achievement. And then, as you say, you look at Greece, you look at the Greek literature, and then you look at the Library of Alexandria, which the knowledge was lost because the barbarians came and burnt the thing down. You realise that civilizations rise and fall, and knowledge can be lost. And the Romans, I suspect, thought they were eternal as a civilization. They would continue to progress. The Greeks before them thought that. The Egyptians thought that. They didn't. We think that now. And it's interesting to reflect, I think, on the fact that you don't have to make progress. The progress is in your own hands. So you can choose to make progress. They didn't choose to make progress for various reasons. They stopped making progress and they vanished, and their knowledge vanished with them a lot of the time. And I think it's a lesson for us. We could do that. You know, we just, maybe we've got into this position now with our technology where it just won't go like that. But I don't think we can take it for granted, which is, I think, goes right back to the start of the conversation about how do we say to people, you know, this is a remarkable thing that we've done. But don't take it for granted. It's not just going to tick along while you guys sit there and watch sports all the time. Right? That's not the way that you make progress. Somebody's got to do something. And we've all got to support the people. Even if you don't want to do it, then support the people that want to do it. So you look at I was filming with on Friday for a thing I'm doing in Britain with Rusty Spigott, who's Apollo 9. So he test flew the lunar module on Apollo 9 in 1968. First test flight of it in Earth orbit before they went to the moon in July of that year, so we landed on the moon actually in a simulator. It was terrific, and he showed me how to do it, and it's fantastic. But you look at NASA. The investment in NASA at that time, it was never more than 4% of federal expenditure, and actually it was often less than that. So it wasn't particularly expensive. It was, on average, maybe about 3% of federal expenditure. But it laid the foundation, I could argue, for American technological dominance in the last quarter of the 20th century. Because, for example, the average age of the engineers in the NASA mission control when Apollo 11 landed on the moon was below 30. Below 30 years old, those engineers. So what happened to them after the Apollo program? They went out to work for Boeing and, Microsoft. Bell Labs or Lockheed Martin or whoever it is, all these people. So and you get this explosion in technological achievement, in economic growth. America's a terrific place to be because, in many ways, because of the growth that happened in those 30 or 40 years since Apollo. But that was because of a conscious investment led by, Kennedy's great speech and also inspired by the Cold War, etc. There's many reasons why he did it. But ultimately, that investment paid vast dividends. You look at NASA today, and the investment is way down. So the ambition that America had to go to the moon because it's there, and to beat the Russians, but to do it. And then that ambition seems to be missing to me. And I looked to this country, actually, because I think it is the country. No other country could have done that. No other country could have gone, moon will go, I think, before this decade is out. We'll go. And they hadn't flown anyone in space when Kennedy made that speech. You hadn't flown anyone in space. And you say, within 10 years, I'm going to walk on the moon. That's an American thing to do, I think. It's part of what's great about this country. And I regret the fact that doesn't seem to be there at the moment. And going back to why I started saying that, the idea that progress comes to the bold, right? I would say so. The idea that it will just come, that we'll just make progress, is not necessarily right. In fact, history tells us it's wrong. So you've got to have, I believe, bold visions, visionary leaders, and leaders will just say, well, this is not a great deflection of resources It was, as I say, it was always less than 3-4% of federal expenditure. But it's a great deflection of national will. And it's a great generator of a sea of engineers and scientists who are inspired by those things and trained in that process that go out into the economy and make the economy better. There's a study that suggested there was a 14-to-1 return on every dollar invested in Apollo by 1980. And people can argue about was it 10-to-1, was it 14-to-1, was it 20-to-1?
Is the return to the private sector or return to the government?
Into the GDP, into wealth
and
generated.
Tang.
So each one
They made Tang.
each one of those dollars generated
Right.
at least 10 and maybe 20 in a decade. And it's obvious how it did it because look at those young engineers and look at the technologies that were developed for Apollo. Someone said to me at NASA Ames up in San Francisco, virtually every technology in commercial aviation today got invented there at NASA. Ames, actually, most of it. So you can point to one place and go, that's where everything I take for granted when I get in an aircraft came from that, right, almost directly.
Do you think it's because of the ending of the Cold War, the lack of competition with Russia? We were on top, so we just got soft. There's no need to keep pushing and pressing. There wasn't an adversary. There wasn't this technological adversary that's out there that gives people the motivation to continue to invest 4% of the gross domestic product or whatever the amount of money we need.
Yeah, I don't know. It seems. If I look at Britain, so I talk about my country, which did the big thing, ran the world and then declined, and doesn't run the world anymore, handed it over to you guys.
Well, you guys had a little island. You ran it out of an island, which is pretty dope.
Yeah.
We have a big-ass continent.
Yeah, I think we just set off from the wrong place.
You guys did it out of Rhode Island. You know?
Well, yeah, it's kind of smaller than California, isn't it?
Yeah, it's pretty crazy.
So we did well for a while.
Not bad.
But it seems to me that what we lack is... these things are not expensive. In fact, they're vital. They generate money. So it seems to me it's leadership. It's visionary leadership, I think.
Inspiration.
Yeah, and it doesn't take... Well, I was going to say it doesn't take much. Clearly, it took a Kennedy, I think. I mean, that speech is a remarkable speech that rallies a nation behind something. But it's not a particularly large diversion of resources. That's the point. And certainly, given what you get back, it seems to me that investment in R&D, in science and technology and education, these are the things that form the foundation of our future. Absolutely. And everybody agrees with that. And I get very involved. I get involved in politics in Britain, but not party politics, but lobbying for this. Spend money on the young, spend money on the education system, spend money on inspiration, make sure that there's a generation of these great engineers and scientists that America is currently world leading in, absolutely, and make sure that they're still there. And how do you get them? How do you inspire them? I don't want kids to want to be singers, actually, particularly on X Factor. I don't want them to be famous. There was a survey done recently, I think, where they said to loads of school kids, what do you want to be when you grow up? And a lot of them said, famous. Famous? What do you mean? Famous? You want to walk on the moon, don't you? You want to invent the world's fastest computer, don't you? Do you want to? What do you mean famous? You've got to be famous for something. It's not famous because you want a talent show. We go back to the poor Kardashians. I've never seen the Kardashians, by the way. I don't know who the hell they are, and thank God I don't, because I don't know. I don't think we have them in Britain. I don't think, maybe we do. But
they get over there.
Do they get over there? We don't.
I'm sure.
But I don't want to pick on that lot. I mean, they're doing what they do, right? But the point is, you don't want to be one of those. I mean, without being disrespectful, maybe they're having a good time.
You're so British.
Money,
you try to insult people and then not at the same time.
I don't want to insult people who kind of make their way, and do well. And
but they're not criminals. They're not evil people. No. They're not the scourge of society.
But the point is, what do you want to aspire to be as a kid? What do you want to aspire to be? And it's true that in the 60s they wanted to be Neil Armstrong or one of the engineers in Mission Control. And that's a government has... I know it's kind of unfashionable in some circles to say that, but government sets the direction. It has to. Companies can do it as well. So you have the big companies like Apple and Google who've got so people do aspire to work with those companies. But I think the grand direction of civilization is set by governments and visionaries, and it's not expensive. But it's terrifically expensive not to do it.
Well, governments, the idea of government has really been hijacked in this country, and it's become about money.
Being careful, it's good. It's unfair. And I know, it depends what you mean by government and big government and small government.
Special interest groups and lobbyists, and
it's complicated.
There's just too much money involved.
It's complex.
There's legal, absolutely legal corruption in this country, like where giant corporations are allowed to invest enormous sums of money into candidates that will, once they get into office, do the bidding of these corporations, manipulate laws, move things around, make things easier for these corporations to manipulate our society. That's a reality, and that's very unfortunate. But I think that's a reality that's also being eroding, or is eroding rather, by technology. I think people understanding the mechanisms involved in government is making them want to change those mechanisms. People pushing for ideas like being able to vote online. This is like, people are really frustrated by this. Like, how come I can bank online? How come you can deal with the entire world's economy through computers and the internet, but you can't vote? How come? Is it because you don't want it to be that easy for people to give their opinion and people to vote? Because the world of the internet and the world of actual voting, there's a big gap between them. There's a big gap that would instantly shift right over if you were allowed to vote online. And there's people that say, oh, there's problems with that, oh, corruption, oh, this, or you're the one who's always worried about hacking. Well, guess what? That's going to be the case no matter what you do. There's all sorts of problems with voting the conventional way. I mean, in America, we've had giant scandals and Diebold voting machines that contained third-party access, the ability to manipulate the data. It's all been proven. There was a documentary called Hacking Democracy that showed how ludicrous it is to think that our system that's in place right now is infallible. Not only that, it's massively flawed. The technology that exists because of the internet, because of the ability to exchange information instantaneously with each other, is unprecedented. And I think that is going to shift the idea of government. It's going to scatter all these crazy people that are running things right now. That's not going to be viable anymore, just like kings aren't viable anymore. You can't be Henry VIII in 2015 unless you're the guy in North Korea. He's like the last one. But most governments can't be run the way they were run thousands of years ago. There's too much access to information. We know you're not a god. We know you're just a person. You know, we have this ability to exchange these ideas so quickly that the word gets out too fast.
Well, that's what I mean. If you listen to Tim Berners-Lee when he talks about the World Wide Web, and invented, by the way, at CERN, of course, the web bit of it.
Yes.
And then he talks in those terms, actually. You feel it's quite idealistic, Tim Berners-Lee.
I am too.
The freedom of information, free exchange of information. And I think you're right. I mean, it goes right back to the beginning of the conversation, doesn't it? Is the internet a good thing or a bad thing, or the web, let's say, a good thing or a bad thing? And you must be right in this sense, that as long as people, you know, you need a certain... We're having this conversation at quite a high level. You know, we're talking about great movements and great shifts in civilization, so I suppose you need the perspective first, don't you? You need your appetite stimulated for knowledge and information, and not to use the internet or the web to ghettoize yourself. You need to have some instinct that I'm not going to just go find the little sliver of information that interests me, and perhaps information that's nonsensical. And there's also how you can go and be a conspiracy theorist and find plenty of information to support your conspiracy.
Reptile
so that toolkit, Sagan always
Right.
talked about this in The Demon-Haunted World, again, about giving people a toolkit, bullshit detectors, I think he called it. You know, the education, science, the scientific method, that's a bullshit detector kit, basically. So if you can get that in, maybe this is the priority really in schools, to say, well, I want you to know how to think, how to look at information, assess where the information came from, understand if it's likely to be tainted or biased or good or bad, or how do I assess this vast quantity of information out there? How do I not ghettoize myself? How do I not decide that I'm only going to exist on forums that say that we didn't land on the moon and there was a big conspiracy and everyone covered it up? How can I broaden my reach to say, is that really true? Shall I check some other stuff, like the telescopes where you can look at the spacecraft on the moon? You know, that kind of bits of evidence. You know, so I think that's very important.
Is it ironic that in this day and age we accumulate more data? I think there was some statistic about in every 2 days we accumulate more data, more like numbers, and a lot of it's like probably Instagram pictures and Twitter and shit that's useless, but that more hard data gets accumulated or processed or produced by humans today than the entire time of human history
that's right.
up to that point, which is fucking staggering.
Yeah.
But
yeah.
it also, most of it takes place on computers. Most of it is ones and zeros. Most of it takes place in a language that you and I can't even read if it was written on a piece of paper.
No one, and it's a big subject. How do you use that data? And how would we use it? There's an example. The program I do in the UK called Stargazing Live, which is a live astronomy show on the BBC. And lots of people watch it. It's kind of, people like it. One of the things that we do are citizen science projects. So, for example, last year, that we used the European Space Agency's database of photographs of the surface of Mars. Nobody's ever looked at them. Right, there's too many of them. So we've got too many pictures of Mars. No human eyes have ever looked at these pictures. So we ran a project where we wanted to answer a question about some features that were seen moving across the surface of Mars, weather features that we thought may be seasonal. So maybe in the Martian winter they moved down to the equator and then moved back up again in the summer. Didn't know. And we proved that they were indeed seasonal by getting millions of people who watch the programme to go look at the pictures for the first time. So you can go online now and look at pictures of Mars, let's say, that nobody's ever seen. Because there's too much data, even of another planet. So imagine the amount of data generated on this planet that no one's ever done, no one's ever looked at. There'll be data about what increases the likelihood of certain cancers, for example. There'll be the lifestyle that does that and doesn't. That'll all be there in the data. But no one's quite got their head around how to go and mine that data and try to use it. Just using the data is extremely difficult and challenging. But you're right, it's there. No one ever looks at it.
Well, not only that, the idea of somehow or another preserving this. If there was some event, supervolcano eruption, like they're constantly worried about Yellowstone, and there's one in Indonesia, I believe it is, that they believe is connected to a mass extinction event that killed off a giant swath of the population.
Oh, they're nasty, those supervolcanoes.
Terrifying.
We don't want one of those to go up.
And if one of those hits and somehow or another the power goes out all around the world and the only people that survive are those folks that live by the volcano, fuck, man. We're starting from scratch? Like, I mean, relatively in terms of the universe, that's nothing. So, you big baby, you got to wait another 10,000 years for civilization to reemerge and someone to reinvent the internet, you know, and the Ark of the Covenant and still locked up in Ethiopia because they already did this and they already figured out how to make a little nuclear bomb or something like that. Who knows what the fuck it is? But for our immediate life, it's so critical to not just acquire this information, but to nurture it and to spread it. I mean, that's your whole idea, right? You're just talking about expanding science and education and getting people excited and involved, but all that doesn't mean jack shit if the fucking Earth spits out a giant ball of lava that engulfs half of North America and kills 90% of the planet. Like, we're starting from scratch, and none of this is going to be any good. No computers, no hard drives, no flash drives, no fucking database. It's all bullshit. The cloud, go fuck your cloud. It's not really in the cloud. I got news for you. It's down on Earth. It's in the cloud. No, it's not. There's no cloud. Okay, it doesn't exist. You go up and look around for your fucking data. It's not there. It's in someone's goddamn building. Okay, it's in a fucking building. Stop saying it's in the cloud, because it's not. That's a dirty, stinky lie. You know? I mean, that's reality. Unless you're launching that fucking shit up, taking all the hard drives of all the world and launching it into space, and on a 10,000-year loop, so it comes back around and lands. You do it 99.9% of the speed of light.
Can you imagine
so
that?
The data,
they'll get it back again.
Yeah,
and they go,
it comes back around.
They go, you did that? You what?
Could you imagine if that's what happens? Like, one day, they pick a strategic location that they believe will be a large population of life, and it re-lands 10,000 years later, and we go, oh fuck, look at this, look at all the shit they knew, and it's all in DOS or whatever, something that we could read like fairly easily. They run it through some computers, and they realize, like, wow, fucking people have been around.
Do you remember my first operating system on a PC was DOS 5? Do you remember that? DOS 5.
I was post DOS. The first
DOS.
computer that I ever had Windows 95, and Windows 95 was the big deal. My friend Chris made computers with Windows 3.2. He preceded me.
3.1, which you ran on DOS. So I had no Windows when I got my first PC.
Wow,
it was cool.
That's crazy. Yeah. And if you think about how recent,
hard drive, 40 meg.
Yes, it's nothing.
You can't get an email on that.
Yeah, right. If someone sends you a picture, it's way bigger than that.
40 meg.
Yeah, every fucking picture is 100 meg, right?
Yeah.
And if you think that was 1995, it was only 20 years ago.
Yeah.
And in 20 years, a blink of an eye, you know?
Yeah.
A blink of an eye.
I think we should go back to DOS.
You think so?
Yeah. I might.
Why?
Because you had to know how the computer worked. You had to have these little autoexec.bat files that sort of
But is that
allocated
good?
the memory.
Isn't that like more work than you need?
It's a big deal in a sense because we have a problem with getting kids to write code because they all sit there on PS4s and things.
Well, it's a
like
lot
that,
of
and
work to write
Xboxes.
code, right?
Yeah, but in the old days with the computers, you
I
had
have
to do
friends that make video games, and one of the most shocking things was the sheer amount of hours that go into coding video games.
Yeah.
You know, the folks at id Software, they let me in behind the scenes, and Epic Games too. Cliffy B, our friend Cliffy B, who's been on the podcast before. I would watch those guys work. They would do 16-hour days, and they would just be coding and drinking fucking caffeine and just staring in front of these monitors and just running over thousands of lines of code, and you're like, oh, that's how you make a fucking video game?
Yeah, they're kind of $100 million things, aren't they?
Oh!
They're just unbelievable. They're like movies.
Well, they're bigger than movies. The average huge game, like a Grand Theft Auto, when those games get released, the amount of money that they generate is rival to like Avatar, some huge spectacular hit. Like not an average movie, but a just gigantic, monumental, epic, huge successful movie.
Yeah.
That's like an average video game.
Yeah.
You know, Grand Theft Auto and Madden, when those Madden games come out, the fucking world changes. Like, I mean, people generate, there's so much income that gets poured into those video games. And you realize that it's a lot of just people just coding, just standing in front of computers and just pounding on the keyboards. It's madness.
You know, maybe that's the way that Western civilization falls.
The coders, people stop fucking them.
coders.
That's what's going to happen. They're going to stop breeding. That's what's going to happen. Women will stop having sex with
Darwinian.
coders, and it's all going to fucking end. All their accumulated knowledge we were talking about before, like the coders making children that are better coders, nope, just ends.
Yeah, and it'll be
One
back
day.
to people like me who can write Fortran.
Yeah, one day we wake up and we realize that no one's making video games anymore. So we go to these places where they made video games. Like, hello, everybody's dead, cobwebs everywhere. They just died and no one fucked them.
The
And-
apocalypse. No more.
Well, imagine if computer coders ceased to exist and all of us were forced to back engineer computer code. If today, like for somehow or another, I don't know how many people in this world have a deep understanding of computer operating systems or computer code, but I couldn't imagine it's more than 1%. And if we lost 1% of the population, just disappeared from the earth, and then the rest of us dopes were left to observe our cell phone crashing or our fucking TriCaster over here that shit the bed on us mid-broadcast, I mean, if we'll just that's a critical part of our society, of civilization itself, and it totally overlooked. So you coders out there, mwah, God bless you.
But keep breathing.
Yeah, keep breathing, and may you breed, breeding, and breathing.
We need to
that
supply
too.
them with a, yeah.
Praise Odin for
way.
the coders. It's amazing. It's amazing if you really think of how much our life and our civilization revolves around electronics and around computer code.
We should do a monkey cage on this, actually.
Yes.
Yeah.
I mean, it's
We should-
stunning.
should
If
go
you
back
really
and do some
stop and
more.
think about it, every single thing that used to be mechanical and analog is now computer. Like cars. This is the main, for car enthusiasts, it's one of the main complaints, is that you don't feel what a car is doing anymore. One of the thrills of driving an older car, like especially an old sports car, they're not as fast, they don't handle as well, but you feel everything. You feel the road because it's a mechanical steering. There's no assisting. Like if you go to like a 1973 Porsche 911, there's no hydraulic assist in the steering. It's all mechanical. You feel every pebble. You literally feel the mechanism turning the tire. You feel the tires losing their grip. It's all transmitted through your seat and through your hands. And people live for this. It's like exciting stuff. But if you drive a modern Porsche, it's like there's a million operations that are going on behind the scenes, and every second to avoid collisions and slow your tires down and braking on the right side because you're turning left. There's like all this shit that's going on that you don't even know. You don't even feel it. There's a magnetic ride control system that's adjusting. There's certain cars now, like I believe Mercedes-Benz has a camera that looks at the road in front of you and gauges whether or not the suspension should be compliant or rigid. It adjusts, and you can go, I think, up to like 30 miles an hour. You just take your hand off the wheel and put it in cruise control, and it fucking turns based on the lines on the road.
Do you think that the first sentient being is going to be a 911 sentient artificial being?
I hope it's an American car. I hope it's a Corvette, or maybe perhaps a truck, maybe an F-150. Takes out godless heathens, just drives around, eats assholes. I wonder, I think for sure if we can live, you and I'm 47. How old are you?
47.
47. So if we could live if we get really lucky, we live another 50 years based on modern interpretation of science and medicine.
I'm actually 46, by the way. I'm 47 in March. Just because that'll get letters.
Oh,
They'll
people
go,
get
"He can't
mad?
add up,
Fucking
He works at
liar.
CERN, he
Well,
can't add up."
at least you added the right way.
47-ish.
You know? If you're like, I'm 40-ish. I have a friend who won't tell me his age. Ian Edwards. He won't tell me how old he is. Motherfucker. I think he's my age, but he won't say it.
Actually, I should have said 47 because then Wikipedia will change.
Yeah.
It'll be very funny.
Wikipedia is wrong about a lot of shit.
It's full of-
It still thinks Brian Cowan's my brother. It still thinks I'm 5 feet tall. If you consider this idea that if everything goes correct and we live to be 95 years old, let's go there. For sure, there's going to be something. There's going to be they've already got these little Japanese talking head ones that look eerie, very strange, sort of artificial faces that talk to you. There's going to come a point in time as the exponential increase in technology, whether it's 20, 30 years, where they're going to make fake fucking people, man.
Tell you what, let me plug something else, nothing to do with me. There's a friend of mine, Alex Garland, who just made a film called Ex Machina, which is a great science fiction film, which will be coming to the States. It's just been released in the UK. Ex Machina.
Ooh, can I get it online somewhere?
Yeah,
legally?
Not legally, I suppose.
Oh, illegally? Can I get it legal? That's a problem, you fuckers.
But it's
make it legal so I can get it. Ex Machina.
You'll see the trailer on. You can get the trailer on YouTube, and it's been released in the States. Can't remember when, but it's great. And it's about an AI, a female AI. And it's about a guy kind of like one of these Elon Musk type guys who lives out in the woods, and he's built one of these things, and he gets one of his employees to come and do a Turing test on it, which is to see if he thinks that this thing is sentient, this AI, but she's beautiful, and it kind of goes off from there. But Alex wrote The Beach, and he wrote 28 Days Later. So it's a really brilliant science fiction film, but it explores some of these issues that we've been talking about what it is to be human. Are the AIs better than us? Are they better than us morally, physically, strength? What is it? Why is this girl so beautiful? Why did he make this beautiful woman?
Right.
It's a great film. So I recommend that to everyone who's listening.
That sounds amazing. When is it going to be released here?
It must be very soon because it's just been out in the UK. It did very well. It was out in.
Is it going to be released in theaters, or is it going to be a digital release?
April
10th in America.
It's
Beautiful.
a great film.
Wow, that's a great concept. I mean, that I've said for a long time that I believe the first artificial intelligence would be sex slaves. People are going to make artificial sex people.
Yeah.
People that you can have sex with. Like, is it cheating to use a device? Is it cheating to masturbate? Some people say yes. I was reading a forum article where these people are arguing. This guy's arguing with his wife. She's saying if he doesn't stop masturbating, she's going to divorce him. Specifically to porn.
Did she argue with his hand? So the unfaithful, the device of unfaithfulness.
Just beat his hand up.
Yeah.
But then, it goes from masturbation to masturbation using technology, meaning the internet to watch pornography, to masturbation using a device. Like they have these, you know what Oculus Rift is, I'm sure, right?
Yeah, that's good, actually.
It's amazing.
I had to go with that.
The new version of it, my friend Duncan called me up. I was at the Improv, and when he called me, I was about to go on stage. It was like 5 minutes before I go on stage, and he had just got back from some 3D virtual reality conference, and he was just screaming at my phone, "It's a fucking game changer, man! This is the craziest shit!" He said that it was the HD quality was stunning.
I did ago. Sony let me have a look at the one that there's an Oculus and something else they're using for the PS4, which is it's not out yet, but it'll be out in 12 months, I think, something like that. It's amazing. They showed me this demo, and it's that HD real. It's like it's
Stunning
really
stuff.
very, very good. I think that is going to be a game changer.
Well, they decided to do first-person pornography with these things. That's supposed to just be like, there's a real issue that people are going to have with being addicted to this stuff, because I don't believe that our minds. I think one of the reasons why people have such a deep, what we were talking about earlier, that people get angry at dumb programming, and people get angry at dumb songs and dumb television shows. One of the reasons I think we have this instinct to get upset at it is I think we inherently understand that we're not designed to process the media that we've created. We're designed to imitate the successful behaviors of other tribal members. We're designed to listen to people like you talk and be inspired. But you're right here. I'm looking right at you.
Evolved.
Right.
Evolved, not designed.
Okay, well, I don't mean it in that sense. I mean in the sense of this is how we function.
Yeah.
Evolved. I'm sorry. I don't mean design.
Yeah.
But if you take that into consideration, what about a screen that's 60 feet tall and Brad Pitt comes on and his bone structure is fucking perfect, and if it's not, they manipulate it and make it perfect with 3G CGI, and every time he talks, music's playing, and every word out of his mouth is carefully considered. Although it looks spontaneous, it's not. They've carefully considered this for weeks and weeks for maximum impact on your psyche. And you're sitting there and the music's playing and he kisses Angelina Jolie and we're not designed for that. So our very existence, the world that we live in, our model of it is based like 90% on bullshit, 10% on real life experiences, 90% on movies. And I have a friend who got in a fight with a guy, and the guy said to him while they're about to fight some drunken thing, "Prepare to dine in hell. Tonight we dine in hell." He yelled out a fucking quote from a stupid movie, like when they're about to fist fight. They were fist fighting, which could potentially lead to death. I mean, when you're involved in actively trying to hurt another human being, all fucking bets are out the window. This is chaos, right? And the guy's yelling out a movie quote, "Tonight we dine in hell."
This could be the beginning of a beautiful friendship.
We're
just
fucking
confuse
crazy.
the hell out of him. Just start randomly shouting quotes back from the great.
Yes.
We're off to see the wizard. Trying out crazy him.
Frodo, you are my brother. Yeah, I mean, we're crazy. I don't think we're. The inspiration that I get from songs, like there's songs that I'll listen to, there's certain like weightlifting songs. I swear when you listen to those songs, you can lift more weights. You can work out harder. Like you're tired, you're on the elliptical machine. Queen comes on, like Dragon Attack, and you fucking you see, your body reacts to it. You have a physiological response to media, to something that's been created that doesn't exist in nature. With all of nature's majesty, with fucking waterfalls and flowers, it never figured out how to make sound come out of a headset that's just incredible and just makes your fucking goosebumps raise up. We've created some weird shit, and in creating that weird shit, we're altering our very version of the reality that we observe with our real senses, our eyes and our ears and our fingers, and we're changing it. And this Oculus Rift shit is gonna take it to a whole new place. I mean, it's gonna be as addictive as reality TV is with its stupidity. It's gonna be way more addictive if you could look at any part of those people while they're talking. I mean, you could do whatever you want. You could move around in their world while they're existing. You don't have to have a real life.
Have you seen Wall-E?
I haven't.
Wall-E. Go
Yeah.
watch Wall-E.
Was it good?
Yeah, it's great. It's a great film. But everyone just ends up, every human is basically a fat, useless slob that floats around, can't even walk, and is just on a big space liner floating around in space. Useless. Just gone, watching TV.
Well,
being
that's certainly
force-fed
pessimistic
food and-
version of reality.
That
What do you
it's a
think?
great
What's
film.
your version of reality? This is
And
because
that
we're wrapping up.
Wall-E's-
We're running at 3 hours in. We turn into a pumpkin.
Yeah, right.
So we're right about there. Like,
What's
what do you think is going to happen with us? Are you pessimistic? Are you optimistic? Do you enjoy the way in direction we're moving ultimately?
Our scientific and engineering achievements are astonishing and going beautifully well. I think it needs. I don't think it needs. I'm optimistic, I think, But I think it just needs a little. I'm slightly pessimistic at the moment. I think it just needs this little nudge. I think just we've in countries like ours, right? We've got these education systems and these universities that are broadly speaking very good. They need a bit more money, but they're pretty good. And we've got a culture that allows us to be open-minded, and we have democracies, and all these things are very difficult to get. So I think we often miss the great things that we have in place in places like the US and Europe. Definitely, really very good. And so it just takes a recognition of that, I think. And that's how we started again, isn't it? How do you just remind people what wonderful opportunities they have and what wonderful things there are to do? And if you just turn the reality TV off for a bit and go and read a book or something, a Kindle book if you want, it doesn't have to be a real book, but then, what wonderful things could we achieve? So I'm kind of optimistic there, I think. You
Beautiful.
have to be, don't you?
Beautiful. I think so. I mean, obviously, there's some real issues with culture and society, but I often wonder, as we talked about before, if those issues just inspire us to improve and change. And if you can't have a yin without a yang. I mean, you have a bunch of shit going on that is like a constant ebb and flow. And I always ponder whether or not that is almost a mechanism for progress or a mechanism for advancement, and that without it, you don't get that. I don't know.
It's possible. It is possible. So we can be optimistic at the end of the podcast.
Yes, I think we wrapped it up nice. I think we brought it home in a beautiful way.
And can I say, just because my promoter's sat over there, and I know he's been sat there for 3 hours, he would like me to remind the viewers that the Infinite Monkey Cage tickets are available online. So
InfiniteMonkeyCage.com.
Yes. So you're on the LA one, which is the 12th of 12th of March.
Yes, at the Ricardo Montalban Theater. How ironic that Fantasy Island, the guy from Fantasy Island, that's who Ricardo Montalban was, that we're going to be at the Ricardo Montalban Theater. One of the dumbest fucking shows ever. Fantasy Island. That had a little midget, boss, the plane.
Yin and yang.
Yes.
As you said.
See, it's all coming together.
The dumb theatre, the great show. And then we're in San Francisco the day after, New York and Chicago.
All the dates are available at InfiniteMonkeyCage.com. Thursday, March 5th, they're in NYU at the Skirball Center in New York City.
Neil deGrasse Tyson's doing that one, actually.
Yes, Neil deGrasse Tyson, astrophysicist Jonna Levin. Did I say it right? Jonna, J-A-N-A. And then March 7th at the Athenaeum Theater in Chicago. With Paul Serrano, paleontologist, and evolutionary biologist Jerry Coyne. And then, of course, the 12th with me and Blossom, the girl from Blossom. She's on the Big Bang Theory, right?
And
She's
the guy who
to me.
wrote Futurama is there, David Cohen.
David Cohen, Emmy award-winning writer.
Secret as well. There might be a Python around.
Oh, and you got one March 13th about UFOs, alien probes, and other close encounters. Oh, I want to be on that one.
Do you?
Damn.
You should can't
make it. Can't go to San Francisco. I'm busy that day. Listen, you're fucking awesome, man. Thank you very much.
No,
Thanks for existing. Thanks for doing what you do, because it's so important. It's so exciting to me to be able to watch your shows and to be able to just sort of sponge that information from you. And thanks for just keep on keeping on, man.
Because I'm going to see you in 3 weeks in LA.
Yes.
So I'll bring the Human Universe stuff for you. I'll bring you some. So you can watch it.
That's it.
Or download
folks.
it on the torrent.
Yes. Do whatever you got to do. Do whatever you got to do, folks. Get by. All right. We love you. Thank you. See you soon.
Thank you. Enjoyed that. Cool.